Hello students. So today we are going to discuss the physics part of FT-05. So let us start. The first question is, in the given diagram, if the string connecting B and C, this one, is cut, then what will be the accelerations of the blocks A, B, C and D at the same instant, not after a long time? So let us start, and I'll draw the free body diagram here only, the forces only. On A, the weight mg, that is 1g, I'm writing 1g here. The spring force here will be same, 1g. So here is spring force will be same, 1g. Here the tension will be what? Its weight, 2g. And 1g, 3g. So here the tension will be 3g. Here also the tension will be 3g. And its weight will be 3g. So spring force here will be 3 and 3, 6g. So here also the spring force will be 6g. And the weight would be 4g. So the spring force here would be 10g. Now, the moment we just cut this string, then what happens? These springs won't be having this news that the string has been cut. Suddenly there won't be any change in this configuration. So what happens to this? 1g, 1g. So its acceleration will be 0. There won't be any change. It's in equilibrium for the time being. Here, downwards 3g. Upwards this tension vanishes because this string is being cut. So its acceleration will be downwards, and that is what? 3g divided by 2. So 3g by 2 downwards. What about this? This tension, 3g, gone. So the net force will be 6g up minus 3g down, that is 3g up. So 3g up by 3 kg is 3g by 3. So that is g in upward direction. So clearly we can see only for these 3 accelerations, it's here. 0 for A, 3g by 2 downwards for B, g upwards for C, and let us see for D also. For D, 10g, 10g. So acceleration here will also be 0. So the second option is the correct one. The only change will be these two tensions. This tension on this block, this tension on this block, just vanished. Next, the radius of the earth is about 6,400 kilometer. So I'm writing, and that of Mars is half of that. The mass of the earth is 10 times the mass of the Mars. So let us write G on earth by G on Mars is G ME by radius of earth square over G into mass of Mars over radius of Mars square. So obviously GG got cancelled. The Earth's mass is 10 times. Yani ME by MM is 10. The radius of Earth is double of this. So we'll get 2 to the 4 here. So by 4. So this is 5 by 2. So after cross multiplication, we see that G on Mars is 2/5 that on Earth. So if the weight of any object on Earth is something, then 2/5 of that will be the weight on the Mars. So weight on Mars will be weight on Earth 2/5. So 2/5 of 200 is 80 Newton. So the first option is the correct one, 80 Newton. Let us move to the next question. and that is the instantaneous displacement of a simple pendulum oscillator is given by x is equal to a cos omega t plus pi by 4. Its speed will be maximum at what time? We can use phasor. It's very simple question. Huh? Okay, it will work. So for cosine function, if t was 0, cosine function starts from here. So it's omega t plus pi by 4. That is at initial time, it's pi by 4 ahead. That is, it's here. Its projection would be somewhere here at a by root 2, and it would be moving this way. So this is the way. The speed or the velocity will be in this direction. So guys, the velocity or the speed will be maximum when it comes here. So what's the angle to be traveled? It's pi by 4 again. So this is 1/8 of the total one oscillation, that is 1/8 of 2 pi. So the time taken from here to here would be t by 8. So 1/8 of time period, which is 2 pi by omega. So 1/8 of 2 pi by omega. So this is nothing but pi by 4 omega. So it's very simple. Pi by 4 omega, the first option. Next, a body is moving uniform acceleration. What's the initial speed is not given. It travels 40 meters in first 5 seconds and 65 meters in next 5 seconds. Then what's the initial velocity? Let us take initial velocity as u and the constant acceleration as a. So for the first part, we can use distance traveled 40 s is ut. The time is 5, so 5u plus half a and t square. T square is 25. Half times 25a. This is the first equation. Now we can see very clearly in first 10 seconds it will travel 40 and 65, that is 105 meters. So we can write 105 meters is ut, that is 10u, because we are taking it in 10 seconds, plus half a into 10 square, that is 100. So half into 100 a. These are the two equations. If we'll cancel the a term, if we'll remove this, then we'll get a. So this is 25 by 2, this is 100 by 2. So it's better to multiply this equation by 4. So multiplying this equation by 4, what will we get? 160 is 20 times u plus 100 times a by 2. And this equation will be as it is, 10u plus 100 by 2 times a. So now if we will subtract, then what we are going to get? This is minus, this is minus, this is minus. So got cancelled. So 20u minus 10u is 10u. So this is 10u, and that would be 55. So obviously u is 5.5 meters per second. So we can write finally u as 5.5 meter per second. So the initial speed is 5.5 meters per second. The third option is the correct one. Now the next one. Next one, the fifth. These are the two terminals, the plate 1, the plate 2. The total distance between them is, between the plate is 6d. Area is not given, but we'll consider a. No, it's given a. So now we have 3 capacitors because 3 slabs have been inserted. First one's dielectric constant is K, 3K and 5K of next. So these are in series. So 1 by the final C, the C equivalent will be 1 by C1, that is epsilon naught A by D K times. So epsilon naught A K by D. This is D, this is K. The next one, epsilon naught, area is same A, and dielectric constant is 3K. So 3K over 2D. And here it's 3D, so 3D over epsilon naught A and 5K. So as we can see, D by epsilon naught AK is everywhere. So if we'll take this common, D by epsilon naught AK, then we are left with 1 plus 2/3 plus 3/5. So this we can handle like D by epsilon naught AK, 15, 15, 5, 9. Sorry, 5 more, 10. So this is 34 by 50, 1 by C. So we can just reciprocate it, then C will be 15 by 34 times epsilon naught AK by D. So this is our answer, which is in first option. So we got our answer. Let us move on. This is a very direct question. A rod is rotating with omega about one of its ends. L is the length, B is the magnetic field into the plane of the screen. Then what would be the EMF induced in this? It's quite simple. L is the total length about this. Let us say this is rotating this way. So let us consider this as origin. Then at a distance x from here, let us take an element of the rod of length dx. And obviously the velocity would be x omega. The velocity here will be x omega. V is r omega. So now this is the length, this is the velocity, and into the plane of the paper we have uniform magnetic field B. So BLV will be the EMF induced, and all the cells, all the EMFs would be in series. So simply we have to integrate it. So directly I'm writing E would be integral of B, L and V, and X will vary from 0 to L. So here we are going to get B omega, X square by 2, so L square by 2 minus 0 by 2, that is B omega L square by 2. This is the answer, half B omega L square. So C is the correct option, the third one. Guys, you can remember this or memorize this directly as a result. You can use it at so many places. Okay, let us move on. An inductance coil has a reactance of 100 ohm. Reactance means its total impedance net. When an AC signal of frequency 1000 Hz is applied to the coil, the applied voltage leads the current by 45 degrees. Okay, the self-inductance of the coil is, guys, phasor we can use. So this is R and this is XL. Then this would be the net impedance Z. This is given 45. So obviously this also is 45. This is net Z, which is 100. So this is 100 ohm. So obviously XL and R both would be same, because this is 45 degrees. So this and this both are same. So R is not given. So we don't need to bother. XL is omega L. Omega is 2 pi F. So this is 2000 pi. 2 pi into 1000 times L. And same, R will also be the same. And R, let us say x, then this hypotenuse will be root 2x. So root 2 times this would be 100. So root 2 times 2000 pi L would be 100. So we can just cut it. So L will be 1 by 20 root 2 pi. We can do one thing. We can multiply by 100 up and 100 down. Then what happens? 20 5 ja 100. So this is now 5 by root 2. 1.414 into pi is 3.114 into 10 raised to minus 2. So guys, this is roughly somewhere 4.3 or 4.5. So 5 by 4.5 will be 1.1. So 1.1 into 10 raised to minus 2 would be the correct answer. So this is 1.1 into 10 raised to minus 2 Henry. All the things were given in SI units, ohm, hertz. So this will be in SI unit Henry. So the inductance is 1.1 into 10 raised to minus 2 Henry. Let us move to the next question. Two infinite planes, each with uniform surface charge density sigma, are kept in such a way that the angle between them is 30 degrees. It's shown here. The electric field in the region shown between them is. Guys, we can draw a clear diagram. This is 30 degrees. So somewhere here, the field due to this will be this way. Sigma by 2 epsilon naught. And due to this way, sigma by 2 epsilon naught. And obviously we can see this angle is 30 degrees again. So the two components of this would be cos 30 this way. Cos 30 is root 3 by 2. So this is root 3 by 2 times sigma by 2 epsilon naught. And sin 30 is half. So half of sigma by 2 epsilon naught towards left. So as this is x-axis, this is y-axis. So along x, it would be negative of this. So we can write negative of sigma by 2 epsilon naught half times x cap or I cap. You can write here, they have written x cap and y cap. So we'll use that. And along y, sigma by 2 epsilon naught, if we'll take common, then 1 minus root 3 by 2. So plus sigma by 2 epsilon naught 1 minus root 3 by 2 times y cap, we can say. So this is our answer. The electric field here, somewhere in between them, is sigma by 2 epsilon naught 1 minus root 3 by 2 times y cap minus half times x cap. Yeah. So B, second option is the correct one, guys. So it was a really simple question. Let us go to the next one. If 1 mole of monoatomic gas is mixed with 1 mole of diatomic gas, then value of gamma for the mixture is. So we know the gamma for the mixture is 1 plus 2 by F of mixture. And what is F of mixture? F of mixture is N1 F1 plus N2 F2 by N1 plus N2. As the number of moles of both the gases are 1 and 1. So this is for monoatomic, the Degree of freedom is 3, and for diatomic it's 5 because no specific temperature is given. So this is 1 into 3 plus 1 into 5 over 1 plus 1 is 2. So this is 4. So we'll put this back here. Then we'll get gamma of mixture is as 1 plus 2 by 4. That is 1 plus 1 by 2. That is 3 by 2. That is 1.5. So the B option is the correct one. Mixture of these two gases has gamma as 1.50. Oh, now two rods of copper and brass of same length and same area of cross section are joined as shown in figure. One end is kept at 0 degree and the other one at 100 degree. They have not specified which end at what temperature. The temperature at the midpoint would be what? At the junction, what would be the temperature? They are asking. Conditions are given. More than 50 degrees Celsius if A is at 100 degree and B at 0. So let us take anything. The reverse condition is here. So let us take 100 here and 0 here. And T that of the junction. And they have said that K, the conductivity of copper is more than brass, that of brass. So let us see the heat current here in copper would be same as heat current in brass rod. So let us write 100 minus T delta T divided by L by AK. So the length is same, area same, and K is K of copper. This would be same as delta T here, that is T minus 0 times A and K of brass divided by length. So as we can see, A and L got cancelled. Here 100 times Kc minus T times Kc would be T times K brass. So we'll take this that way, then we'll get T as 100 times Kc by Kc plus K of brass. And we can clearly see if Kc is greater than this, then obviously this would be more than half. This is simple inequality. Like let us take Kc as 3, then 3 and this as 2. So 3 by 5, which is obviously more than half. So more than 50 it will come. So more than 50 if A is at 100 and B is at 0. So A is correct. And guys, if we would have, chosen this opposite, then this T would come as 100 times KB by KB plus KC. So which will be less than half. So that is not there. So obviously A is the correct option. So let us now move to the next one. 2 kg copper block is heated to 500 degrees Celsius and then it's placed on a large block of ice at 0 degrees Celsius. If the specific heat capacity of copper is 400 SI units and latent heat is also given, then the amount of ice that can melt is, it's very simple. The amount of heat this copper ball will lose, that will be utilized as latent heat to melt the ice. So let us equate it. M C, what's the C? Specific heat capacity, it's 400 SI units, MC, and delta T. From 500 degrees Celsius, it can come the least as 0 degrees Celsius. So the temperature difference is 500. So MC delta T would be the unknown mass of the ice. We don't know. So let us take it M and L. What is L? It is 3.5 10 raised to 5. Okay. So very simple calculation is there. So M can be the 4 powers we just cut, then we got 10 only. So M would be this 40 and divided by 35. So 5 8 and 5 7. So this much kg, 8 by 7 kg of ice can be melted. So it's here the C option. So simple, direct. Let us see the next one. String is cut into three parts having fundamental frequencies N1, N2 and N3 respectively. Then original fundamental frequency N related to the expression as other quantities are identical. Then what is the relation? Guys, we know the fundamental frequency for any stressed wire fixed at both the ends is fundamental frequency is V by 2L. So N is V by 2 times the length, and length is what? L1 plus L2 plus L3. Similarly, we can see for a single part, its fundamental frequency is N1. So N1 would be V by 2 times L1. So guys, from here we can see L1 to be V by 2N1. And similarly, we can see L2 is V by 2N2, L3 is V by 2N3. So we'll substitute those relations here. Then we are going to get N as V by 2. Let us take this 2 in numerator. Then L1 is V by 2 N1. Same, so V by 2 we can take common 1 by N1, 1 by N2, 1 by N3. So guys, these two got cancelled. So we can see 1 over N would be this. So simply we are getting a relation 1 by N as 1 by N1 plus 1 by N2 plus 1 by N3. So it's here in first option, the A. Let us move on. White light is used to illuminate the two slits of a Young's double slit experiment. The separation between slits is B. The separation, this is the slit and this is another one. This is the central line. Let us say this is the screen. So in front of one of the slits, they are asking. So this is our Y. Obviously, capital D, which we were calling, it's given here D, and this is B. So this Y will be B by 2, obviously. And they are saying, at a point on a screen directly in front of one of the slits, certain wavelengths are missing. Means for those wavelengths, this is the point of minimum intensity, point of minima. That is, destructive interference should be there. Okay, that's great. So we know that this Y must be 2n plus 1 times lambda, the capital D we were saying now, the distance between the slits and the screen, by small d, that is the distance between the slits. And 2 would be there. This is the condition for the points of minima. So these two got cancelled. So we can see lambda would be B square by this odd number 2n plus 1 times D. So now we'll look here. If we'll put n as 1, then we'll get 3. If we'll put n as 0, we'll get simply B square by D. So yeah, B square by D is here. B square by 3D is here. 2 by 3, not possible. 2 by 3, not possible. So obviously, sorry, this is 2 by 1, not 3. 3 is the option. This thing. So not possible. So the two values are 1 and 3. So the first option is correct. Because for these two wavelengths, that will be the point of minimum intensity. Okay, next. A final image formed after two refractions, one refraction, then reflection, and again refraction. The refractive index is 1.5 of this lens's material, and one reflection from the mirror forming at same point O. Then D is equal to what? The distance between lens and the mirror is what they are asking, and this distance of the object from this lens is 80 centimeter. First surface's radius of curvature is 10, second surface's radius is 20, and the radius of curvature of this mirror is 30 centimeter. Okay, so guys, let us first find the focal length of this lens. So 1 by F, L I am writing, is mu minus 1, that is 1.5 minus 1 is half, into 1 by R1 minus 1 by R2. So 1 by 10 minus 1 by 20 is 1 by 20, half 1 by 40. So basically this is 1 by 40. So guys, we can see if focal length of lens is 40 centimeters. So this point is basically 2f for this. So obviously the image would be formed at 2f. That we don't have to use again the lens formula 1 by v minus 1 by u is 1 by f. You can do. Then you will get the image will be formed at 80. Now there are two conditions. The two cases I'm just telling you guys. Either this is directly 80, then a ray will go like this, the same angle, like this, and then this. So basically this is going one, this is after reflection coming back. So image will get here only. Either this, or another way is that, let us say that this is 80, and this is 30, such that the ray coming would be normal incident on this. So it will retrace its path and it will go back there. So 80 plus 30 is 110 centimeter or 80 centimeter. 110 is not present here. So obviously guys, 80 centimeter is our answer. It's also really simple one. Now the next. A transparent solid cylindrical rod has a refractive index of 2 by root 3. It is surrounded by air. Air is outside here. Light rays incident at the midpoint of one end of the rod as shown. The incident angle theta, they are asking for which the light ray grazes along the wall of the rod. Here like this, they are asking. So guys, here the angle of refraction is 90. So obviously this would be critical angle for this with respect to air. If this is theta c, the critical angle, this would be 90 minus theta c. So I'm writing here, this is theta c, and this angle, which is angle of refraction, is 90 minus theta c. Now we don't have anything other than Snell's law. So let us use Snell's law at this interface. Then it will be mu1 sine I, that is theta, sine theta, should be mu2, which is 2 by root 3, and sine of this r, sine 90 minus theta, is cosine of theta c. So this is cosine of theta c. Now another thing, we know that sine of the critical angle is 1 by mu. Mu is the refractive index of the denser medium with respect to the rarer one. So we also have sine theta c as 1 by mu. So root 3 by 2. So guys, we can also find cos theta c directly using the formula, or we can do one thing. If this is theta c, then this is sine theta c, yani root 3, and this is 2. So this will be 1. 2 to the 4, 3, 1. So cos theta c is half. So simply we got 2 by root 3 times half, which is simply 1 by root 3. So sine theta c is 1 by root 3. So sorry, theta. So theta will be sine inverse 1 by root 3. So again, this question was quite doable. Sine inverse 1 by root 3. Simple use of Snell's law and the concept of critical angle. Now, a silver ball of radius 4.8 cm is suspended by a thread in vacuum chamber. UV light of wavelength 200 nanometers is incident on the ball for some time, during which a total energy of this much joule falls on the surface. Assuming on an average 1 out of 1000, there was a misprint here, 1000 photons incident is able to eject electron. The potential of the potential on the surface of a sphere will be what? Guys, let us find the number of photons incident on that ball. So let us take that was small n. So small n times hc by lambda and lambda is 200 nanometer, that is 2 into 10 raised to minus 7. Now we can do one thing, we'll put all the values finally. So hc by lambda, and this is the total energy, which is 10 raised to minus 7 joules. So this is number of photons incident. Now they are saying 1 out of 1000 photon can eject an electron. So number of electrons ejected would be n by 1000. So from here we can get n as 10 raised to minus 7 lambda over hc. So number of electrons we got as this 10 raised to minus 7 lambda by hc times 10 raised to 3. I will solve it further. Now potential of the sphere will be kq by r, that is k, and q is what? Number of electrons into electronic charge. This is kq by the radius of the sphere. Simply we have to put the values, and guys, after putting the values, I'm not going to do the calculative part, or if you want to see, you can see k is 9 into 10 raised to 9. Number of electrons is 10 raised to minus 10. Lambda is 2 into 10 raised to minus 7, 200 nanometers. By h is 6.6, 10 raised to minus 34. C is 3 into 10 raised to 8. 10 raised to 3 is there. So this is Kne, and electronic charge now we have to put. So 1.6, 10 raised to minus 19. And again in the denominator, radius, which is 4.8 centimeters. So 4.8 into 10 raised to minus 2. It's looking like ugly calculation, a lengthy or hectic one, but it's not such a long one. 8 and 3. Let us deal with the 10 base powers. So 8, 3, 11. 11 minus 2 is 9. Minus 34 plus 9 is minus 25. That will go up, becoming 25. 25 minus 19 is 6. 6 minus 7 is minus 1. Minus 1, minus 10, minus 11. Minus 11 plus 9, minus 2. So 10 raised to minus 2 is there. And the remaining numbers, 9, 2, 1.6. 18 times 1.6 over 6.6 into 3 into 4.8. 6.6 into 3 into 4.8. 16 3s are, 3 3s are 9, 9 2s are 18. So this is 2 by 6.6 into 10 raised to minus 2. Are we missing some more? No. This was not misprint. So out of 10 only if we'll do. Wait guys. This is only 10, not 10 raised to 3. So this will also go. This will also go. So this will be 10 raised to 1. 10 raised to 1, that is 10. So 20 by 6.6 is nearly 3 volts. So calculation was not too tough. And we got the C, 3 volt. Yeah, lengthy, so many quantities. Okay, next. A typical nuclear fusion reaction is given by deuterium, tritium, and hydrogen. This and the Q value is 4 mega electron volt. For this one, it's 17.6 mega electron volt. They have added it, so new reaction. The new Q value is 21.6 mega electron volt. Now they are asking the energy released per nucleon of the reaction is what? So total 6 nucleons are there. So the energy per nucleon will be 21.6 mega electron volt divided by 6. So this is 3.6 mega electron volt, obviously per nucleon. B option, simple. It was again quite simple. The next one. In the figure shown, the current in the 10 volt battery is close to what? Guys, we can do, there are two ways. One, we'll consider this as a cell, and then we'll find the equivalent, and then we'll find the current here, and then we'll write the, we'll use Kirchhoff's law to go from here to there, and then we can find the current in this 4 ohm resistor as well as this battery. Or we can do another thing. We can go this way, that let us take the loop currents. Let us say this is I1 and let us say this as I2. Then obviously in this I2 only, in this I1 only I1, in this superposition of both the loop currents, that is I1 plus I2. So we can write two equations for I1 and I2 for the two different loops. We can solve them, we can find I2 directly, and that would be our answer. Let us see. For the first one, I'm starting from here. So I1 times 2, we are getting drop. So minus 2I1 plus 20 minus 5I1. Here the drop again 10 times I1 plus I2. So minus 10I1 minus 10I2, and we got at the same place, so it's 0. So guys, this is 17I1 plus 10I2 is 20. 17I1 plus 10I2 is 20. The first equation. For the second loop, guys, we can start from here. So in the direction of current, we'll get a drop. So minus 4I2 plus 10. Again the same, minus 10I1 minus 10I2, and again 0. We reach the same point. So minus 14 I1, sorry, minus 10I1 will go that way, 10I1 plus 14I2 is 10. Now we have to, eliminate I1 from these two equations, and we'll get I2 directly. We can do one thing now. We can write it 5I1 plus 7I2 is 5. This is the new second one. Now we have to substitute or remove I1. So we can multiply this by 5 and that by 17. So let me write here. This multiplied by 5 and this multiplied by 17. Then this equation will be getting as 85I1 plus 50I2 is 100, and here it will be 85I1 plus 17 7 ja 119, I2 is 85. So guys, now it's very simple. We can do this, then these two got cancelled. 50 minus 119, so this is 69. So minus 69 I2 is 15. So I2 will be minus 15 by 69. So guys, obviously if we'll round it to 70, then 15 by 70 is somewhere 0.21, very little greater than 0.2. So this is 0.21 in only one option, and the direction is, as I2 we have taken this way, but we got negative, which means the actual direction of current is this way. So from positive plate to negative plate, and the value is, you can see, minus 2.1 amperes. So the C option is the correct one. So this is, we have to solve two equations. That way also we have to find equivalent EMF, the internal resistance. So this is good. Let's see the next. Yeah, here is the another method. Now the 19th one. Two wires have the same diameter and the same length. One is made of copper and another of brass. They are connected together at one end. When free ends are pulled in opposite direction by the same force, then the wires will have same strain. No, because the Young's moduli are different. The wires will have the same stress. Yes, because same force, same tension, same cross-sectional area. Both the wires will break at the same force. No, because Young's moduli different. Both wires will have same elongation. No, again. So the second option is correct, guys. No need to even draw the diagram. The 20th. 1 mole of monatomic gas undergoes the process P into T is constant. Then the molar heat capacity of the gas during the process will be equal to what? Guys, this is a polytropic process. So polytropic process, normally if in this form P into V raised to alpha is constant, then for this specific heat, molar specific heat capacity is CV plus R by 1 minus alpha. So guys, somehow if we will convert this in this form, P into V raised to something, then that something will be the polytropic exponent. So let us try to do. Another thing, there is one word missing here. It's ideal gas, obviously. There is no real gas mentioned here. So obviously we can use PV is mu RT. So guys, for temperature we can write PV by mu R. Again, the number of moles fixed are constant, universal constant. So in place of T we can write PV. So if we'll substitute this here, then we'll get P into T. So T is again PV by some constant mu R, that is another constant, let us say C. So P raised to 2, V raised to 1 is another constant. So we can take square root. So we can write P into V raised to half is another constant. So see guys, this half is the adiabatic exponent. We cannot say, we cannot tell that. This is polytropic exponent alpha. So we can put this alpha here and we can find the C, molar specific heat capacity, as CV. This is monatomic gas, guys. So for monatomic, CV is 3R by 2. So this is 3R by 2 plus 1 by 1 minus alpha. So 1 minus half is half. 2 will go up. So R by 1 minus alpha. So this is 2R, this is 1.5R. So this is 3.5R. Or we can write 7R by 2. Yeah, in option C, it's 3.5R. This was also a good question. Now, the 21st, integer type. A projectile is moving at 20 meters per second at its highest point. Okay. Let us see, this is the diagram, let us assume. Then, where it's break into equal parts due to an internal explosion. One part moves vertically up at 30 meters per second with respect to the ground. Then other part will move at what speed? Okay. So before explosion, the condition was that m was the mass of the object moving with a speed 20 meters per second. Let me change the color, that will be understandable well. It breaks into two parts. One part, obviously, of mass m by 2, it's moving upwards at a speed 30. So what about the another part? Okay, so before explosion, the ball was not having any component of the momentum in vertical direction, but in the new scenario, we can see this part is having some momentum vertically up. So this second half will also have to be the same momentum downwards so as to cancel the vertical components. So the m by 2 will have the same 30 in downward direction. Now the responsibility of having the original momentum maintained, this second half, m by 2 only has the responsibility. So mass is halved, so speed will be doubled, obviously. So this will be 40 meters per second. So simple, guys. So this second ball will have this much speed. Net we can write this way. So 40 and 30 will be 50, and this angle would be obviously 37, because this is 3, 4, 5. So our answer will be 50 meters per second. So this is 50. So it was simple, guys. Next one is 22nd. Yeah. Photoelectrons are emitted with a maximum speed of this 7 into 10 raised to 5 meters per second from a surface. When light of frequency this much hertz is showered on it, the threshold frequency for this surface is this much. Then what is x? The power of 10. Guys, h nu will be h nu th. The threshold frequency, corresponding energy is the work function. This is the energy incident. And then plus Ke max, which is half mv square. We have to find the threshold frequency. So we can write nu th will be nu minus half mv square and divided by this h here. So simply we'll put the values and we'll do the calculation. Excuse me. The frequency is 8 into 10 raised to 14 minus mass. Mass of electron we have to consider, so it is 9.1. Let us take 9 into 10 raised to minus 31. V square, that is 49 times 10 raised to 10 by 2 times h, that is 6.6 into 10 raised to minus 34. Let us do the base 10 things, 10 raised to powers. So minus 34 will go up. Yeah, so it will be 3, 10 and 3, 13. So 8 into 10 raised to 14 minus 9.1 into 49 over 2 into 6.6 into 10 raised to 13. We can solve this. So this is around 50, this is around 9, so this is nearly 450. So this is 450 by 13.2, we can call it as 13. Then this is something 14 threes are. We can take this 10 here, then we will get, let me write it again. 45 by 13 times 10 raised to 14. And here we were having 8 into 10 raised to 14. So guys, 10 raised to 14 is common. This is roughly nearly 3. So this is nearly 5. So it's quite simpler. Simply 4.64 into 10 raised to 14. Hertz will be the threshold frequency. So our answer is 14, guys, the power. So this is 14. We got it. So actually this happens in real JEE papers also. They won't give you too much hectic calculation. You can set them. Okay, let us move to the next one, 23rd. 27 identical drops are charged at 22 volt each. Okay, let us take, guys, small q is the charge on one small ball. They combine to form a bigger drop. Then the potential of the bigger drop will be simply, guys, kq by small r is 22. Now k into 27q by 27 small drops will combine to make a single big drop. Then radius will obviously be 3 times, because, guys, you can see 3 raised to 3. So by the radius is 3 times r. So this is v dash I'm writing. This was v initial. This is the new one. So this is 9 times kq by r. Which one is the previous one? So 22 into 9 is 198 volts. And that's our answer, 198. So it was very simple, guys. Simply we conserve the volume to find the new radius, and we just conserve the charge, 27q. This is the charge, this is new radius. It was simple. 24th. There is a test charge, okay, q, moving the velocity v. Okay, this is v, 2i plus 3j meters per second. In a magnetic field, v 2i plus 3j Weber per meter square, you can say, or Tesla. Okay. Excuse me. Then the magnetic force on the test charge. Wow, guys, there is one very interesting thing. The direction of velocity vector and magnetic field vector both are same. And as we know, the force is qv cross b. So the cross product of two parallel vectors is always 0, because sine theta is involved. So, guys, 0. Or maybe 0.00, as you will get there. 0 is the answer, guys. There won't be any force because the charge is moving parallel to the magnetic field. Yeah, it's 0. Now last, 5 molecules of a gas are having speeds 1, 2, 4, 8 and 16 meters per second at some instant, at any point of time. Then the RMS velocity of the gas molecules will be what? N by 10. They are asking n. So, guys, V RMS will be root of mean of square terms. So 1 square plus 2 square plus 4 square, 8 square, 16 square over 5. So we took the average, the mean of square terms, and finally we will take the root. Okay? 1, 4, 5, 16, 5, 21, 21 and 64, 85 and 256. 256 and 85 over 5. So, guys, this is 1, 3, 4, 2. 2, 4, 1. Sorry, 3, 4, 1 over 5, the square root. So we can write it 5, 6 ja 30, 0.458 ja 40 and then 1. That is 0, 2 or something. Oh, no. Wait. 68.2. So square root of this. Guys, square of 8 is 64. And that of 9 is 81. It is very close to 64 in comparison with 81. So obviously this will be close to 8, square root of this. Let us try once, 8.2. Because 8.1 will be very small. 1, 6, 65. See, guys, this is 65.61, which is very less. So let us once try 8.2. 2 2 ja 4. We are not going to find the square root by long division method, obviously. So 4, 16 to the 32, 3, 67.24. It's very close. It's very close, because next 8.3, if we'll do, this will exceed by a larger amount. 68.89. So it's exceeding. So we'll write 8.2. So guys, this is 82 by 10, and this was the format. This was n by 10 they have given. So obviously n is 82. So here we are done with the entire paper. Yeah, let's check the answer. Yeah, it's 82, the same. So, okay guys, I hope the discussion went very well and you enjoyed. Thank you.
So hello everyone. I'm hoping that you all are good and your preparations are going really well. So I'm here. I'm Pradeep Kumar. I'll be taking the chemistry discussion for today's paper. So let's start the discussion. So the first question is from kinetics. Zero order reaction. So the question reads that you got a zero order reaction. So let's write that order of the reaction is 0, and you have to tell the plot of concentration A minus X versus time. So what is A minus X? So for any reaction, A going to be at T equals to 0, whatever concentration you have, you call it A naught. And at the time of the moment when you are observing this reaction, at whatever time you are going to observe this reaction, the concentration of A remaining is AT. So A minus X is nothing but the final concentration at the given moment. At the given moment, whatever is the concentration of A remaining, that is what you are calling A minus X. And A naught is A, the initial concentration, the amount that you took. A naught was given to you A, and AT is A minus X. That means X amount has reacted from the reactant. So you have to tell what is the graph of A minus X versus T, meaning basically you have to tell AT versus time. AT versus time, what is the curve? If you want to tell the curve for anything versus anything, you need to know the mathematical relation between them. So for zero order reaction, we know the relation that AT comes out to be A naught minus KT. This is the relation between AT and A naught. AT, which is nothing but the A minus X, A naught, which is the initial concentration, value being A, K being the rate constant, and time, the time at the moment at which you are observing this reaction. So you have to plot AT versus T. So let's take the axis. Let's keep AT over here. AT, which is nothing but A minus X versus the time. You clearly see AT, let us say this is Y, and the time, the another variable, let us say that is X. Between A naught for a given reaction, you already have this thing as constant, and K, the rate constant, is also constant for a given reaction. So we see this reaction comes out in a format Y equals to mx plus C, where m equals to minus K and the C equals to A naught, means there is a non-zero intercept. You will always start with some amount of reactant. So C is never going to be 0. C, which is the intercept for this equation, this is never going to be 0. And the slope of the reaction is going to be minus K. Slope is minus of K. K is a positive quantity. Minus of that means the slope is negative. So the correct option for that would be this. You will eliminate negative slope, correct, but it's a 0 intercept. So eliminated. Positive slope, eliminated. Negative slope, that's correct. And non-zero intercept, that's correct. So slope of the reaction, this is going to be the curve for this. Slope of the reaction is minus K, and the intercept is A naught, which of course is not 0. So the correct answer for this will be D. I hope you understood the solution. Let's move on to next question. This is the solution. Next question. This is from chemical bonding. You have to tell that which of these following compounds have the highest lattice energy. So lattice energy, as you are aware, that lattice energy is directly proportional to the charges on the ions that they have and will be inversely proportional to size. Now let's look at the question. We have cations in these. All the cations are from the first group. We have Li plus in the first one, Na plus in the second one, K plus in the third one, and Cs minus in the fourth one. These are first group elements. They are ions. These are the ions of first group elements. As you go down the group, size increases, but the charge is constant. So charge is not going to decide the lattice energy order in this. So charge is constant, but size is varying over here. As the size is increasing, the lattice energy will be decreasing. If you see, but just you need to check both the ions, not just the cations. So as per the cations, we see that here Li plus will give you the maximum lattice energy and Cs plus will give you the minimum lattice energy. But that will be when the anions are same. Here we see the anion is F minus. Here we have the Cl minus. Here we have the H minus. Here we have the I minus. Okay. So if you see that H minus is the smallest, but the problem is K plus. K plus is larger. Larger size of cation and smaller size of anion. Once again, all the anions have the same charges, -1 only. So charges is not the differentiating factor over here. Once again, the size is going to be the differentiating factor. Basically, that pair where you have the smallest cation and anion, there you will be having the largest lattice energy. So although H minus is smallest, fine, but K plus is large. On the other hand, in LiF, Li plus is also a small cation, F minus is also a small anion. Due to their small sizes, the best balance you get here and you get the largest lattice energy in the first case. So the answer will be option A for question number 2. LiF will have the maximum lattice energy. I hope you understood this. Moving on to question number 3. Which of the following is non-aromatic in nature? Non-aromatic. So you understand that you have aromatic compounds, you have anti-aromatic compounds, and then you have non-aromatic compounds. So any compounds which are neither aromatic nor anti-aromatic, they are non-aromatic compounds. So just identify which are neither aromatic nor anti-aromatic. So for aromatic, you know the condition, the system should be cyclic. For anti-aromatic also, the system should be cyclic. The second condition is system must be planar. Here also, the second is the system must be planar. And the third is system must have a complete conjugation. And here also you should have a complete conjugation. So first three are same in aromatic and anti-aromatic. They differ in the fourth one, the number of pi electrons that you will have. In the aromatic compounds, the number of pi electrons you should have will be 4n plus 2. These many pi electrons you should have. That's Huckel's rule. In this, you should have 4n number of pi electrons. So this is where they differ. If you see the first three are same, they only differ in the fourth one. In the same system, if you got 4n plus 2 pi electron, it's aromatic. If you get 4n pi electron, means the number of electron, if that is multiple of 4. Which electron? Only the pi electrons. Not just any electrons. It should be the pi electrons. Then it will be anti-aromatic. If any of the condition is not met, if any of the condition is not met over here, the compound will fall into the non-aromatic category. Right? So let's see here. Let's check each one of these here. You understand, where as soon as you say the planar, most of the time you get the answer from here itself. If you say planar, you cannot afford to have sp3 atoms in the cycle, in the ring. sp3 atom, that's a big no for a system you are considering to be you want it to be planar. If you want a system to be planar, sp3 is a big no. You shouldn't have any atom sp3 hybridized in the ring. So let's check here. You see this nitrogen, this is sp3 hybridized. Yes, cyclic it is fine, but as soon as we are going to check the second one, planarity, we see sp3. So it is not going to be neither aromatic nor anti-aromatic, because both the conditions should be there. This condition you need in the anti-aromatic also. So here itself we discarded the possibility that it's neither aromatic nor anti-aromatic, so it has no other possibility left but to be non-aromatic. So this becomes non-aromatic. Why? Because of the sp3 atom over there. Let's check others as well. If you see the benzene ring, this is quite popular, you already know. You see cyclic, checked. Planar, all the atoms are sp2 here, checked. Complete conjugation, yes, we have complete conjugation over here, checked. How many pi electrons? 2 plus 2 plus 2, 6 pi electrons. 6 pi electron is 4n plus 2. Just put the value of n, just put the value of n equals to 1. You will see that 6 is the Huckel's number, 4n plus 2. So this compound is aromatic. Same way, if you check this, cyclic, checked. Cyclic, yes. Planar, yes, checked, because each atom over here is sp2. Then complete conjugation, yes, that is also checked. Then the last one, how many pi electrons we see? We see 2 over here and 2 over here. We see 4 pi electrons. If you get the number of pi electrons as multiple of 4, all the first 3 conditions are same for both. If the number of pi electron become multiple of 4, that become anti-aromatic compound. So this is your anti-aromatic compound. Check the last one. Cyclic, checked. Planar, yes, everyone is sp2 over here, checked. How many pi? Okay, complete conjugation, yes, we have the complete conjugation over here, checked. Then last but not the least, of course, 2 pi electrons over here. 2, that is once again the Huckel's number. You already know that value of n can be 0, 1, 2, 3. The n value of n starts from 0 in the Huckel's number. In this, the value of n starts from 1. Take any integer, any positive integer as the value of n. In this, the value of n can start from 0 and then any positive integer. So, number of pi electron is 2. That is a Huckel number. How? Check this. If you put the value of n equals to 0, you are going to see this is going to give you 2. 2 is the Huckel's number. So this is the aromatic compound. So we see B and D are aromatic, C is anti-aromatic, but A is neither aromatic nor anti-aromatic. That's why non-aromatic. I hope you understood this. Moving on to the next question. So what is the potential energy of the electron in the third orbit of hydrogen atom? They are asking you potential energy. Always read this very carefully. What are they trying to ask you? They are not asking you the total energy. They are asking you the potential energy. Potential energy is related to the total energy. How? Potential energy is 2 times the total energy. And the formula that you have got in the Bohr's model, the total energy, that's the total energy formula. You see the formula En equals to minus 13.6 into Z square by N square electron volt. That is the formula for the total energy in the for the electron in nth shell. You don't have to find this, you have to find this. If you want to find this, of course, you need to find the total energy. So, in the third orbit, so just find the total energy in the third shell. E3, is it going to be minus 13.6 hydrogen atom? So Z atomic number will be 1, square of 1 is 1, third shell, so 9. You are going to see this is going to be 1.51 electron volt, right? This is going to be minus of 1.51 electron volt. That is the total energy of electron in the third shell of hydrogen atom. Fine, we got this. Do we need to calculate it every time? I would suggest no. Better you remember the energy of the first 5 shells. You remember the E1 equals to minus 13.6 electron volt, E2 equals to minus 3.4 electron volts, E3 equals to minus 1.51 electron volt, E4 equals to minus of 0.85 electron volt, and E5 equals to minus 0.54 electron volt. If you remember this, lots of problems, there will be many problems which you can solve in just fraction of seconds within 1 or 2 steps. It's not like it's mandatory to remember this, but if you remember, it will be helpful for you. You'll be able to save some time. Anyway, moving on, we have the total energy of the electron in the third shell. It's minus of 1.51 electron volt. Total energy, not total energy, sorry, potential energy. Potential energy will be equal to 2 times the total energy, which is the minus of 1.51. Of course, the unit is going to be electron volt. This is approximately 1.5 multiplied by 2. Answer should be somewhere around 3. 3, this. You can do the multiplication also. You are going to get 3.02 itself. So the correct answer for the question number 4 will be A. I hope you understood this. Very simple question. Moving on to the next question, which is question number 5, and that is from thermodynamics. It says that you got 5 moles of the gases. So let's write number of moles of gases. It's the gas, 5 moles. 100 Kelvin. The gas is initially at 100 Kelvin. So T1 is given to you, 100 Kelvin. That is allowed to undergo reversible compression till its temperature becomes 200 Kelvin, meaning the final temperature is becoming 200 Kelvin. Fine. CV is mentioned to you. CV is given to us as 28 joules per Kelvin per mole. You need to calculate delta U and delta PV for this process. The value of gas constant you have to take is 8. Let's see how to go ahead about this. CV is mentioned to us. Change in temperature is mentioned to us. As soon as we see CV and change in temperature, finding delta U become very, very simple. We know a direct formula which relates this. Do we know this? Delta U equals to NCV delta T. No need to think anything. Delta U, it is nothing but the heat exchange at constant volume. As soon as you see CV and you have delta T given, you don't have to think anything else. Directly come to this formula, you will get delta U. What is it? Let's put the value. N equals to 5, CV equals to 28, and delta T, that is T2 minus T1, final minus initial. So 200 minus 100, that will be 100. Take care of the units. You take the temperature on the Kelvin. The unit of CV is going to decide the unit of the delta U. The CV we have taken is 28, which has joules per Kelvin per mole. So the unit of delta U is also going to be in the joules only from this calculation. So let us do the calculation and see what do we get. We get 5 8s are 40, 10, 14, then 2 more zeros. Unit, of course, will be joules. This is nothing but the energy. So 14,000 joules, if you see the options are given in kilojoules, let's convert that into kilojoule. Will that become 4,000 divided by 1,000 kilojoules, meaning 14 kilojoule will be the answer for delta U. So this, let's eliminate this and this. So we got 3 options which have delta U equals to 14 kilojoule. Now, we have to find delta PV. Okay, delta U we know, delta PV we need to know. Do we have some equation which relates delta U and delta PV? Yes, the very definition of the enthalpy change, the delta H. Do we know this? That delta H equals delta U plus delta PV. Yes, we know this. We have to find this. Somehow if we find this, problem is solved. How to find delta H? Is there any other way to find this? Yes, we have a way. We know the CV, so we automatically know CP. How do we know CP? By this relation. Do we know CP minus CV equals to R? CV is to known to us. So CP, will that be R plus CV? They already have made it easier for you. Take the value of R as 8. So put it 8. Okay. Make sure that these two are in sync when it comes to the units. This has the energy unit of joules. This also has the energy units of joules. So yes, we are good to go. We can simply add them up. 8 plus 28. It will be 36. Again, unit will be joules per mole per Kelvin. So that will be the value of Cp. Just like delta U is the heat exchange at the constant volume, same way delta H is the heat exchanged at the constant pressure. So we can find using this N Cp delta T, delta H. If we find delta H, you understand why are we finding the delta H? Because we find delta H, we find delta PV. Let's solve this. Delta H equals to N value given to us 5, Cp, we got it 36, and delta T is 100, 200 minus 100. Solve this, what do we get? 18,000. What will be the unit? Whatever was the energy unit for the Cp, that's we got in the joules. So delta H will also be in the joules. Delta H is also the nothing but the energy, right? So that will also have the unit of energy itself. So 18,000 joules. In this equation, if delta U, if you're taking in the kilojoule, you should take delta H as well in kilojoule. Or if you are taking this in the joules, you can take this in the joules, then the unit of this will be in the joules. If you look at the options, we are asked to solve delta PV in terms of kilojoules. So better we take delta H in the form of kilojoules and then directly get the answer. 18,000 joules means nothing but 18,000 by 1,000, 18 kilojoules. We know the value of delta H. We got the delta U, 14. Let's put it in the equation, get the answer. So let's put the values. This is 18 equals to delta U is 14. Take care of the unit. I have taken both in kilojoules plus delta of PV. Let's directly get the answer. Delta PV, will that come out to be 18 minus 14 means 4 kilojoule. Which one is the answer? A. That will be the correct answer for this question. I hope you understood this. Good question from thermodynamics. Moving on to next question. This is the solution. Question number 6 from coordination compound. So we have NiCO4 given and NiNH3 plus 2. They say, always read this, do not differ in. Means in what, which of the following they are saying. That's what they mean, correct? So if you want to do anything, it's better that you find the hybridization first, because once you find the hybridization, you get many answers, like the magnetic moment you get, geometry you get. These two you will be able to get directly from finding the hybridization. For oxidation number, you can directly see CO is a neutral ligand. So nickel overall charge over this is 0. So NiCO whole 4, this is neutral. So the charge over this should also be 0. Oxidation number of nickel in this case will be 0. Right? In this case, NiNH3 whole 4 plus 2. NH3, it's a neutral ligand. So no charge on this, 0. On this, let us say X. Can we directly solve it? X, the sum of oxidation number of each should be equal to the net charge. Right? First chapter, redox reaction. Put the values. X plus 4 into 0, 0 equals to net charge. We see X equals to plus 2. Or you could have directly told. In this charge, net charge, is because of the atoms over here. This carries no charge. So that plus 2 must be because of this only. So Ni is in plus 2 state. So we can directly eliminate option number B now. Option B, sorry, not option number B. My bad. We can eliminate option B now. Oxidation number of nickel. It's 0 in here, it's plus 2 in here. So no, that's not our answer. So that's why it's suggested that you find the hybridization first. You'll get the clearer picture. Let's find this for EN. So you can directly find effective atomic number. So what you can do here, nickel atomic number 28 plus 4 ligands, monodentate. Each ligand brings you 2 electrons. So 4 into 2, 8. So EAN over here will be 8 plus 28, 36. Yes. Here, nickel 28, but Ni plus 2. So it got 26 electron. 26 plus monodentate once again NH3. One NH3 gets 2 electron here. So 4 would get 8. 26 plus 8, 34. No, EAN is not same. I hope you understood this. All that you have to do to find the EAN is nothing but write the atomic number, see what charges you have, charges meaning the oxidation number, and then how many electrons ligands are bringing. Simple. It's a very simple thing. The main battles between these two, and these both can be answered only if you know the hybridization. Let's see. NiCO4. First thing, keep in mind, this is a strong ligand, carbon donor atom, right? This is a strong ligand. If it is a strong ligand, what will it do? What it can do? It can do a lot. It can force the pairing. You understand that? Correct? So nickel over here is in 0 state. Nickel 0, atomic number 28. What will be the configuration? Will it be argon 4s2 3d8? Yes, it will be. It's 3d8. Let's see. This is your 3D, 5 orbitals. And this is your 4s, which got 2 electrons here. Let's see how the electrons are arranged. 3D got 8 electrons. So let's put 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. You got 2 electrons here. Being a strong ligand, it forces this pairing over here. These 2 electrons get paired up in the 3D. So due to the strong ligand, presence of strong ligand here, the configuration would look something like this now, not something like this, exactly like this. So 4s 3D will have 10 electrons now. You see it will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vacant. There is no scope of d orbital to participate in the hybridization. Only option left to this is coordination number is 4. So when you have coordination number 4, you have 2 possibilities in the hybridization. You know that, sp3 and dsp2. We see there is no scope for the d to participate. So only option left is you have 3p orbital over here, 4p. So s3p hybridization will become sp3. So hybridization is sp3. Once you know the hybridization, you also know the geometry of the molecule. For sp3, geometry is tetrahedral. So geometry of NiCO4 is going to be tetrahedral. Okay. How about the magnetic moment? Magnetic moment depends on the number of unpaired electrons. Do we see any unpaired electrons over here? No, we don't see any unpaired electron. If you're wondering that what if CO brings some unpaired electron? No, they are going to give you 2 electrons, right? Ligands, the coordinate bond over there. For the CO is going to bring 2 electron here, right? So you're not going to see any unpaired electron from that. So whatever unpaired electron you have to see here. You see no unpaired electron. Number of unpaired electrons are 0. So mu, of course, will be 0 because mu is n into n plus 2 Bohr magneton. No unpaired electron, 0. Solve this, you'll get 0. It's a diamagnetic molecule. So for NiCO4, we got this. This has no unpaired electron and this has tetrahedral geometry. Fine. Let's check NiNH34 plus 2 now. So same thing now. Let's take it on the next slide. NiNH3 whole 4 plus 2. Check the hybridization. So oxidation of nickel is plus 2. We already have found that. Ni plus 2. Will it have? Nickel had 4s2 3d8. The neutral nickel had this configuration. You are removing 2 electrons. That's how you are saying plus 2. So you, of course, remove the electron from the valence shell. You removed. You are left with 0 electron in the 4s. So it's 4s0 3d8 for the Ni plus 2. What kind of ligand is this? This is a weak ligand. This is a weak ligand. Okay, so what happened if it's a weak ligand? If it's a weak ligand, it won't be able to force any pairing of the electrons. So means whatever configuration Ni plus 2 have in absence of NS3, same configuration it will have in the presence of NS3 also. No change. It is not going to force any pairing. Let's write this. 4s0, 3d8. So 3d got 8 electrons. 5 orbitals in 3d, 8 electrons. So 1, 2, 3, 4, 5, 6, 7, and 8. 4s is vacant. 4p, of course, is vacant. See, have a look at this. Can this be paired? No. If it were strong, it would have paired. It could have forced it to pair. But this is weak one. This won't be able to force it for pairing. So no pairing. So how many unpaired electron remains? There remains 2 unpaired electrons. And as soon as you have unpaired electrons, it is a paramagnetic molecule. This become a paramagnetic molecule. All right. If it has non-zero unpaired electron, surely will have some value of mu. You can find that. Put the values over here. N into N plus 2 Bm. It will have non-zero magnetic moment. Right? NiCO4 had zero magnetic moment. This has some non-zero value. Some value will be there. That means we can obviously eliminate option A also. We already have eliminated option B also. We already have eliminated option D also. So the quite obvious answer becomes C. But wait, we'll justify it here. We understood NiCO4 is sp3 tetrahedral. Let us see what hybridization will nickel take in this case. As it is obvious, no D vacant. So it has to go for sp3 only. So this is also sp3 hybridization. This is also sp3 hybridized. So this will also have tetrahedral geometry only. So the correct answer for this will be geometry. These two compounds do not differ in their geometry. I hope you understood. A fun to do question, a very simple question. But such kind of questions only are asked in JEE. Moving on to the next question. This from the organic chemistry. And you see this. SbCl5, a very strong Lewis acid and very good halogen carrier. To be more precise, chloride carrier. Wherever it sees the chlorine, it removes the chlorine. So SbCl5, it sees the chlorine in the molecule. Let's take the structure here. So we have this here, okay. This, and this. Okay, you understand that this is the structure. Chlorine here, OH here. As soon as SbCl5 appears in the reaction, it takes the Cl minus from here. And if it takes the Cl minus from here, means the chlorine is going to go away with the electron. Will it leave carbon with the positive charge? Yes, it will. So it will leave at Cl minus. So this will remain what? It will form a carbocation. This, and this. Here you have OH attached, and here you got positive charge. Remember this simple mantra. The mantra is whenever, wherever you see C plus, you always see the scope of rearrangement. Remember, rearrangement. Why do we do the rearrangement? We do the rearrangement so that we could make the carbocation more stable. We could take the plus to more stable position. All right? And plus, for plus M stability, it does anything, just anything for the plus M stability. Let's check it over here. Here, on the ring, you have plus M. So whenever you have plus on the ring, you know many types of rearrangement, the hydride shape, the phenyl shape, the alkyl shift and all. When it comes to the ring, you have to be little careful. On the ring, when you see the positive, you think of ring contraction. But 5-member won't contract into 4-member ring because it would become more unstable. So no question about ring contraction over here. If it were, okay, plus on the ring, so no question of the ring contraction. Let us see if there is any other possibility of the rearrangement of the C+. This is also the alpha position to this ring. Just have a look. This is the ring. And this carbon is the first carbon to this ring. So that's the alpha position. Whenever you have positive charge on the alpha position to the ring, it goes for ring expansion. Correct? 5-member tries to convert into 6-member ring. Correct? 4-member tries to convert into the 5-member ring. 6-member generally don't undergo the ring expansion. Here, have a look, 5-member ring. It will become more stable if it becomes 6-member ring, and it has an opportunity right now. What if this bond shifts from here to here? If this shifts, it is 5-member now it will become 6-member. Plus charge will come over here. You know the deal in the rearrangement. From wherever you shift something, there itself you get the positive charge. So since you are shifting the bond from here, so bond will go there, plus will come over here. First thing, what will it become? 5-member ring, remain 5-member ring, nothing happened to that. But this 5-member ring now has become 6-member ring. I hope you understood this. How? It was 5. Now one more carbon is going to be part of this. So it is going to become a 6-member ring. Okay. In order to avoid confusion, you can number it. Correct? See. Let's number 1, 2, 3, 4, 5. You see, 1 will have the OH attached, and 5 will be attached to this carbon. So let's number it. 1, 2, 3, 4, 5. 5 is attached to the carbon of the another 5-member ring. So yes. And then the next carbon is going to be the first carbon. This will have the OH attached. And plus will come over here only, because from here only you had shifted the bond. That's why plus will come over there. So this is the scenario now. Are we going to shift more? No, we are not going to shift it more. It already got plus M stability. So we are not going to do any other rearrangement, any more rearrangement. Now, here, OH, carbon has a positive charge. So the lone pair from here goes here in order to stabilize the plus charge over there. Does it become this? Very simple. Just play with this. 6-member ring over here, 6-member ring over here. Now you are going to see a double bond forming over here. Hydrogen already attached, plus over here. Plus will come on the oxygen. You understand that? Now oxygen removes the H plus in order to neutralize this plus. This has become quite acidic hydrogen now. You understand that? So H plus leaves now. H plus leaves, and now it will become this compound. Just see which one is the which structure corresponds to this. So 5-member, 6-member, and on the first position you have double bond O. Yes, this is our answer. I hope you understood this. This was a classic example of ring expansion as well. I hope you understood this. Moving on to the next question. Question number 8. Question number 8 is from the chemical equilibrium chapter, and based on the concept, the relation between Kp and Kc. We know Kp equals to Kc into RT raised to power delta Ng. This is the relation between Kp and Kc. All right. See, for this reaction, let us see what is delta Ng. For this reaction, delta Ng is the number of gaseous products minus number of gaseous reactants. What numbers? Just take the stoichiometric coefficients. You see there are 2 gases on the product side, 2, and 1 gas on the reactant side. Include only the gases. -1, so delta Ng comes out to be 1. So for this equation particularly, Kp comes out to be Kc into RT raised to the power 1, or you can simply say Kp by Kc will be equal to RT. All right. Question wants to know that what temperature will make this ratio equals to 3. At what temperature this ratio, which equals to RT for this case, will become equal to 3. That's what they want to know. Let's find it. R, the value of R, we know. T equals to, will it become 3 by R? The value of R you have to take is 0.0821 or approximately 1 by 12. 1 by 12 is exactly 0.083. It's slightly higher than this, but for the ease of the calculation, we can use 1 by 12. Why am I using this? Because we see the options. When we look at the options, they are not very close to each other. We see. Let's solve this. So this slight approximation won't harm us anything. Let's put the values. 3 by r. R is 1 by 12. So answer is going to be somewhere around 36. Means 36 point something, because this was slightly higher in value. Slightly higher. So value will be this slightly higher than this. So answer is going to be 36 point something. Let's see which one it corresponds to. Option C. So many times by using the smart calculations, you can save a lots of time. You, of course, you always have this option to use this value of R, do some calculation, waste some more time. I would suggest use the smart calculation and try to save the time. But whenever the options are very, very close to each other, you should avoid the approximations, lots of approximations. So very simple question. Correct answer would be C. I hope you understood this. Moving on to next question, which is question number 9, and a very good question from the chemical bonding. Let's understand this. It says that which of the following is the correct? See, correct. Always read this. Many times it's written incorrect. And in rush, you tend to avoid, you tend to miss that part. So never miss this. Always read the questions carefully. It says the correct order of the increasing bond angle. Okay. So we have to write from the, in the order of increasing bond angle. Let's see which one is correct. NH3. Okay. In the first option, if you see nitrogen, phosphorus, S and Sp, these are the same group member. One thing, these are same type of compounds, same side atoms. When you have same side atom and different central atom, and as the electronegativity decreases down the group, what concept I'm going to apply? Assume, understand this, just take this example. A is bonded with X, let us say 3X. Correct. And then we have another compound B also. It's not boron. I'm just taking it for an example that it's any element which is having the same side atoms, same steric number, but different central atoms. I am saying that electronegativity of A is greater than electronegativity of B. If this is the case, in that case, A is more electronegative than B, so the electrons in this compound will be closer to A. Electrons in this compound will be comparatively away from B, the central atom. Now, how is it deciding the bond angle? It is deciding the bond angle. If the steric number is same, in that case, the electronegativity of side atom, and the central atom become important in deciding the angle, bond angles. Have a look. If your central atom is more electronegative, electrons, shared electron will be closer to it. And if it's closer, these electrons will be closer to each other. Repulsion will be greater. And because of greater repulsion, bond angle will become more. In this case, when the central atom is lesser electronegative, the shared electrons will be away from the central atom. If it's away from the central atom, the distance between the adjacent bonding electrons will be greater, lesser repulsion. They can come at closer distance. Correct? So you understood this. As the electronegativity of central atom decreases, the bond angle should also decrease. Here the bond angle is, electronegativity of central atom is higher. Remember, when are you applying this? When the steric number is same. Side atoms are same. See here. Central atom, if more electronegative, electrons are close to it. If it's close to it, more repulsion. If more repulsion, bond angle will be more. If central atom is lesser electronegative, electrons are away from it. If it's away between the bonding electrons, the distance increases, and so the repulsion decreases. And if repulsion decreases, you can bring them at closer angle. Bond angle will become lesser in this. So this is clearly wrong. Why? You see this, that as you are going down the group, bond angle should decrease, but it's saying that bond angle should increase. So we are eliminating this option, and I hope you understood why. There is another thing, interesting thing, which is that hydrides of group 15 and group 16 beyond second period, meaning starting from third period, in group 15 and 16, they are hydrides. They do not undergo hybridization. Drago's rule, if you remember. So angle is somewhere around 90 degree in them. And the angle in this is somewhere around 107 degree. Little deviation from the tetrahedral angle because of one lone pair. You know that. So that way also we can directly eliminate it. Correct. Option B is really interesting. So we'll discuss it in little detail. Let's see this. So we have H2O, we have OF2, and we have Cl2O. Okay. About these two, you are already aware. You can deal with it based on the electronegativity of the side atom. This is water. This is OF2. And this is Cl2O. All right. See, if you compare these two, these are quite common. You understand that. Steric number for all is same. For all of them, steric number is 4. 2 lone pairs on each and 2 bonding pairs. Correct? On the oxygen atom. So each oxygen is sp3. Here, each oxygen will be sp3. Fine. Okay. Let's compare between these two first. Here, oxygen is more electronegative than the side atom. So electrons are closer to oxygen. Here, fluorine is more electronegative than oxygen. So electrons are away from the central atom. Tell me, when the electron goes away from the central atom, what happens? Distance increases. Distance increases. Repulsion decreases. And if repulsion goes down, these bonds can come closer. So bond angle over here, as the electronegativity of side atom increases, bond angle decreases. You can simply take that as a note. So here, OF2 will have lesser bond angle than H2O. Fine. All right. How about this? Cl2. This is an important compound to consider. Let us see. This is sp3. Fine. This has a vacant d orbital. Does this have vacant d? Yes, this has vacant d. This also got vacant d. This got lone pairs. 2 lone pairs. Fine. Okay. 2 things. I will tell you 2 things over here. One thing is that size of the central atom. The chlorine atom is bigger in size. So if they are bigger in size, due to larger size, you got a repulsion between the groups over here. So repulsion will tend to increase the bond angle. Fine. That we understood. Second thing is that these lone pairs, and there is a vacant orbital. Is something coming to your mind? When you have a lone pair, fulfilled orbital, and vacant d orbital, fulfilled orbital, and vacant d orbital, did you understand that you are going to have a back bonding over here? You are seeing the conditions for the back bonding. So here, the lone pair of oxygen and the vacant orbital of the chlorine, lone pair of the oxygen and the vacant orbital of the chlorine, they are going to participate in the back bonding. What happens if they participate in the back bonding? This happens. Due to the back bonding, the electron density will increase between the atoms. Electron density will increase between the atoms. If the electron density increases between the atoms, the bonds are going to repel even more. And if the bonds are repelling even, there are 2 factors which are trying to increase the bond angle. One, the increased electron density between the bonds, and another one is large size of the group. This is the very reason, because of these 2 reasons combined, Cl2O, this angle theta become greater than the tetrahedral angle also. 109 degree, 28 minutes. It becomes greater than that. To be precise, theta is around 111 degree. So this is one of the compound where the bond angle become greater than the ideal angle, which is the tetrahedral angle. So I hope you understood this. Two regions, large size of the groups and the back bonding. So the correct order should be Cl2O should have the maximum angle, then you should have H2O, and the least angle should be in the OF2. I hope you understood this. Let us see whether you have this order or not. This, fine, but this is where they went wrong. So this is why we'll eliminate this. Let's check option number 3. So tellurium, selenium, sulfur, oxygen. Okay, group 16 members. Okay, we don't have the polonium given here. And we have the same side atoms. When you have same side atom, and steric number is same, of course, you see. Steric number is same. Each one is sp3 over here, right? So steric number is same here. Now, as you go down the group, what happens? Electronegativity decreases, same thing. And if electronegativity decreases, the bond angle should also decrease, and they are following it. Maximum angle in the S3 of the first member and the minimum angle in the last member. Just check this if they are in the order or not. Yes, sulfur, selenium. Yes, correct. That's the correct answer. BF3, BCl3, BBr3, and Bi3. Here, bond angle is 120 degree. So the large side of the group kind of repulsion is not significant. Bond angle is same, 120 degree only here. So I hope you understood this. Moving on to the next question, question number 10. A very good question, Grignard reagent, and you have the carbonyl group, and acid chloride there. All right. R minus, how many you are going to need? That's what they are asking. So here you have the carbonyl group. So R minus, one of the R minus will go and attack here. You understand what happens? This electron shifts. Another R minus will go and attack on this nucleophilic attack. And the double bond O, you understand that RCHO, the R minus from the Grignard reagent, this is the source of R minus, you know that. So R minus, very good nucleophile and very strong base also. So this goes and attack over here, this goes over here. So for each carbonyl group, you need one R. How about the acid chloride part over here? Let us say that any acid chloride part you take, this. So one of the Grignard reagent will be required to do this, and another Grignard reagent will be required to remove this. So you will be requiring two Grignard reagent, 2 moles of or 2 molecules of Grignard reagent for this, one for this, and one for this. Net, there will be 4. Very simple question. There will be 4 moles of Grignard reagent required for this reaction. I hope you understood this. Moving on to next question. The total number of possible isomers of compound, this. All right, let us see. So you have Cu, NH3 whole 4. Okay, they have given you the oxidation number of copper. NH3 being neutral. So whatever is the oxidation number of copper, same will be the charge over this sphere. Here platinum is also +2. So platinum Cl4. Charge will be, just calculate this, what should be the charge? +2 on this, -4. So total charge on this will be -2. So this is the compound given to you. All right. To write this here, to write the isomers, what you need to do, just keep on switching them. You'll see, you just see the number of possibilities that you see. So you have copper here. Let's bring one chlorine in this. If you're bringing one chlorine here, take one NH3 there. So one chlorine here and one NH3. There are 4. There were 4. I moved one NH3 here because I brought one Cl over here. Okay. Take care of the charge as well. It was +2 earlier and you brought -1 in this. So charge is going to drop by 1, +1, and you can do the calculation as well. Here, this thing, platinum, now there will be 3 chlorine remaining and 1 NH3 coming from this. What will be the charge? -1 charge you have taken to this. This is the neutral. This didn't have any impact on the charge. So you have taken 1 minus from here to here. So charge will become -1. Charge will increase by 1 unit then because you have removed -1. Okay. Is there more possibility? Yes, we have. Let's see. Let's move one more chlorine here and one NH3 there. So Cu, Cl2, and then NH3 whole 2. What will be the charge over this? It was +1. You took one more minus here, so charge will be 0. And there is a way to calculate that. You know that +2 here, -2. Total charge 0. Correct. Same way over here. Platinum. It will be left with 2Cl and one more NH3 came to this. So you will have NH3 whole 2. Charge will become 0. Now, take a note here. You cannot have the coordination spheres with the 0 charge. If there is a 0 charge, will you be able to hold these two parts together? This compound won't exist then. Correct? A neutral coordinate compound may exist, but when you have two entities here, these two entities must be held together by certain force of attractions. If though both become neutral and neutral, how are they going to hold each other? So this is not possible. So I guess we won't be able to move any, because if we move even one chlorine here, this will become an ion and this will become cation then. Correct? So we'll stop right here. Now, we are done with switching the ligands. Let's start switching the central atom. Just like for copper you had 2, for platinum also you are going to have 2. So let's switch platinum and copper for this. Let's make one corresponding to this. Will it be platinum NH3 whole 4? And then let's take copper to that. So CuCl4, this. Another corresponding to this, switch it. So will it be PtClNH3 whole 3, then plus, and then another one will be CuCl3NH3. That's all. This will have -1. And if you try to, you understand that the others are not possible, so other switching of central atom will not be possible. So total number of isomers that we see is 1, 2, 3, and 4. So that will be our answer. Very simple. I hope you understood this. Moving on to question number 12. This. The major product of the following reaction. Okay. You have OH group, okay. You have taken it with the acid HCl and you are heating it. Correct? Let's see. When you have taken HCl, let's draw this compound over here. This, and this. And you have OH over here. So HCl is going to give you H+. Now when this H+ is around this molecule, it will look for the basic center. Correct? Basic center means the electron-rich center, the lone pair, the one which have the lone pair. Correct? Which has the lone pair. So let's check who got the lone pair here. This oxygen got the lone pair, yes. This oxygen got the lone pair, yes. This one is in the resonance. So these are delocalized lone pair, and these are your localized lone pair. So these lone pairs are fixed. They're not moving around, but these are moving around. So tell me, which one is more basic? Whenever you have localized lone pair and the delocalized, whenever you have to decide between these two, the lone pair which are localized will always be more basic than the delocalized. So H+ is going to attack here. This is going to provide it the electron. What is it going to be? Protonation taking place here. After protonation, what is it going to become? This remains as OH, CH2, and this become OH2. Oxygen will get a positive charge, ready to leave as water now. This leaves as water. So this leaves as water, what happens? If it leaves as water, of course, this is going to take away the electron. Will you be left with a carbocation forming over here? Yes, you will be. Carbon has a positive charge. It's already regio-stabilized here. So no need to consider rearrangement here. Positive formed. What else we have in the system? We have Cl- also in the system. Nucleophile, it sees the electrophilic center, goes and attack here, and simply the product formed will be nucleophilic substitution reaction. I hope you understood this. Which one is the correct answer? The very first one. This will be the right answer. I hope you understood this. Moving on to the next question. These are still the solutions. Yes, 13. So they have given you the ionization potential 1, 2, 3, 4, 5 of a given element. The values are 7.1, 14.3, 34.5, 646, and 162. Okay, electron volts. The element will be what? Okay, whenever they have given you this, the successive, the value of successive ionization energy, you understand that this is always true, right? IP5 will always be greater than IP4, always greater than IP3. You understand why? Correct. IP2, IP1. So this is always true, right? Energy required to remove the first electron is always least in a given element. Then the energy required to remove the second electron. Then the energy required to remove the third. Like that, correct? Example, energy required to remove the 10th electron will be higher than the energy required to remove the 9th electron, 8th electron, 7th electron, like that. Correct. So this is normal that higher ionization energy potentials will have will be higher in values as well. That is to understood. Fine. But if we see till this, there is a gradual increment, but here there is a sudden jump. We see there is a sudden jump over here. Correct. When do you see the sudden jump? You will see the sudden jump only if you are removing the electron from inner shell. Whenever you are removing the electron from inner fulfilled stable shell, then only you will be seeing the sudden jump in the ionization energy. So wherever, at whatever moment, at whatever point you saw the sudden jump, stop right there. These are the up till this point, the electrons that you have removed, first, second, third, and fourth. Till this, you were removing the electron from the valence shell. The fifth electron is in the inner shell. So number of valence electrons, this will give you the idea of the number of valence electron. You got 4 valence electron, correct? And who got the 4 valence electron? Sodium, no. 1 valence silicon, yes. That will be our answer. I hope you understood this. Moving on to the next question, question number 14, which is this. Question from the mole concept. There is a metal carbonate. This is decomposing according to the following reaction. Yes, M2CO3 solid that breaks down into M2O solid plus CO2 gas. Fine. They are asking you the percentage loss. You understand? Percentage loss in mass. It's not happening that suddenly some mass got disappeared. Law of conservation of mass. Mass cannot get disappeared, right? You cannot destroy the mass. So if you are observing some loss in the mass, that will always be because of the formation of some gas over there. Correct? Let us see, you start with 100 gram and 20 gram of this is formed. Let us say that. I'm not doing any calculation right now. I'm just taking an example. Let us say you start with 100 gram and some X gram of CO2 is formed. So these X gram of CO2 will be lost. You will be left with 100 minus X gram only. So percentage loss in mass is basically the mass of the gas formed. Correct? That much amount only will be the loss. Correct? So basically they are trying to ask you that how much CO2 was formed if you take 100 gram of this. If you take 100 gram of this and X gram forms, X percentage lost. Correct? So that's what they are trying to ask you here. Let's solve this. You can start with any amount here. Apply the mole concept, get the amount, and then find the mass of CO2 forming from 100 gram. Or you can start with 1 mole of this. You are going to get the same answer. You take any variable or you start with 1 mole, you are going to get the same answer. So, because most of you will be taking a variable, that's why I will be solving like you, but I'm telling you this, that you can start with 1 mole also, you will get the same answer, right? So let us say that I have X gram, I have taken X gram at t equals to 0, correct? I took X gram and there is a 100% reaction. From X gram, if you want to find that, let's convert that into the mole first. And if you want to convert that into the moles, you need to find the molar mass of M2CO3. So molar mass of M2CO3, will that be 2 times the atomic mass of M is given to you, 102, plus carbon, which is 12, plus 3 oxygen. So 16 into 3, 48. So you are going to see 60 plus 204, so 264 gram per mole. That's the molar mass of M2CO3. Okay, so number of moles of M2CO3 will be mass by molar mass. These many moles of M2CO3 you are taking for the reaction. You are taking x gram, that means x by 264 moles of the M2CO3. This is a balanced equation. 1 mole of this gives you 1 mole of CO2. So x by 264 moles of this will give you x by 264 moles of CO2. So moles of CO2 produced by x gram of M2CO3 is going to be this. This is the mole. Find the mass. Mass of CO2 will be moles of CO2 into molar mass of CO2. Correct? This much grams of CO2 will be forming from x gram of the M2CO3, meaning these much mass is going to be lost, right? These are going to be the masses which are going to be lost. They are asking the percentage. So meaning from x gram, this much mass gets lost. From 100 gram, how much mass will get lost? That only is your percentage. Let's apply the simple maths over here. Can I say that if you have x gram of M2CO3, the mass lost is x by 264 into 44 grams. If you have 100 gram of this, mass lost will be x by 264 into 44 divided by x into 100. See, if you have observed one thing, I'm not doing the calculation in each and every step. Keep all the calculation for the last step, so that if there is any error, you could directly check the last step and rectify that. Solve this. Now here, this is where you solve. Whatever this comes, this is the mass lost from the 100 grams. That is going to be your answer. Solve this. X and X gets cancelled out. What are you left with? You are left with 44 by 264 into 100. Both are multiples of 11. 4, 2, 2, 4. 4, 4, 6. 100 by 6 means 50 by 3. Have they given in? Yes, 50 by 3. This will be our answer. I hope you understood this. Right? So, how to find this? You understand that? We took the x, that's why it took little time, but you could have solved it using simply considering 1 mole. Starting with 1 mole also, you would have got the answer. Or you could have applied the POAC also, because there is a complete reaction, conserve all the carbon. You could have applied POAC as well. Multiple approach for this problem. I hope you understood this. Moving on to the next question, which is question number 15. Let us see this. Okay. End product they are asking. So you have aniline, 1 degree amine. You are taking it with the chloroform and the KOH and heating. Is this carbylamine reaction? You are going to see the carbylamine reaction over here. What does it do? It converts this into the isonitrile or isocyanide. So this is going to your A is going to be isocyanide fine. And look at this, reducing agent. Whenever isocyanides are reduced, will it convert into secondary amine, NH, and the C is going to be converted to CH3. So correct answer, that is going to be a B. Simple. Carbylamine reaction and the reduction of the isocyanide. If it were cyanide, you would have got primary amine. Since this was a isocyanide, so reduction of the isocyanide will get you secondary amine. Correct answer is A. I hope you understood this. Moving on to question number 16 now. Question number 16. Which of the following aromatic compound is most reactive? Mark this. Towards the electrophilic substitution reaction for the benzene ring. All right. Let us say you have any group attached here. Correct? Any electrophile is going to attack on this. How fast this attack, that will be decided by the group. You understand that? Electrophile needs electrons. Electrophiles, the electron loving species, they need electrons. Anything that makes the benzene more and more electron rich will make it more and more reactive for the electrophilic aromatic substitution reaction. Meaning, what I said, once again, I said that anything that can increase the electron density on this, on the ring, will make it more reactive for the electrophilic attack. Correct? So who makes it more reactive? How can you make it more electron rich? Only if group is electron releasing group. Electron releasing groups are going to make the ring more and more electron rich and so more and more reactive towards the electrophilic aromatic substitution reaction. All right. If you have electron withdrawing, means you are pulling the electron from the system, this become electron deficient. If it become electron deficient, it become lesser reactive towards the EAS or electrophilic substitution reaction. So if your group, if group is electron releasing, reactivity will increase. If the group is electron withdrawing, the reactivity will decrease. This is going to be the principle behind solving this question. Let us see what we have. We got toluene. So we have benzene attached with the CH3. We know this is plus M and plus I, both plus M because of the hyperconjugation. Benzaldehyde, we have benzaldehyde as this, CHO. We know this is minus M group. We have methoxybenzene. So methoxybenzene will be OCH3. You see lone pairs on the oxygen. This is a plus M group. And benzene without any group, this. So whichever group is the best electron releasing group here will make the benzene most reactive towards the electrophilic. So one thing is to clearly understood. If you got electron withdrawing, reactivity will be least. Reactivity will keep on decreasing. With this, stronger the minus M, lesser the reactivity. So this is going to be least because this is minus M. Everywhere in these two, we have plus M. That has nothing. This has minus M. So this is the poorest in terms of the electrons on the benzene ring. So this is going to be least. You understood this? Okay. Most is going to be one of these two, electron releasing. You know that here, this shows plus M because of the hyperconjugation. So it's a weaker plus M than the OCH3. So this OCH3 is the best plus M right now at this moment among these I'm saying. Correct. So this is the best plus M right now here. So that's why this will make the electron, this ring, electron rich at, you understand that, ortho and the para position. Correct. So this makes the ring most reactive towards EAS. So our answer would be C. If you had to arrange in the order, what would you say? You would say that C, methoxybenzene will be the most. Then comes the toluene. Then comes the benzene, and the least will be the one with the electron withdrawing group. I hope you understood this. Our answer will be C according to this question. I hope you understood this. Moving to question number 17 now. It says that compounds of vanadium with chlorine has a magnetic moment. Look at this, magnetic moment 1.73. So you understand mu equals to under root n into n plus 2. Now, are you going to calculate it every time? No, just remember the values for 1 unpaired electron, 2 unpaired electron, 3 unpaired electron. That way you can really save the time. So mu equals to 1.73. That means number of unpaired electron that you need is 1. You need only 1 unpaired electron in the vanadium. Let us see this. Vanadium needs to have only 1 unpaired electron. So let us see how the neutral vanadium looks like. Atomic number 23. So configuration is AR 4s2 3d3. So in the neutral vanadium, you are going to see 2 electrons in the S and 3 unpaired electron in the 3d. As per the question, you need just 1 unpaired. If you need just 1, in that case, you will have to remove these, this, and this. Correct? You need, if you want to have just one unpaired electron, if you want to have just one unpaired electron, even if you don't want to remove, just let's see who can have the one unpaired electron. Only one unpaired electron you need. Vanadium over here in the plus 2. Plus 2 means 2 electrons are removed. If you remove only 2 electrons, you'll be left with 3 unpaired electrons. That's not the answer, of course. VCl3, vanadium and plus 3. If you, in order to have plus 3, you'll remove 2 from here and 1 from here. You'll still be left with 2 unpaired electrons. That's not our answer. VCl4 plus 4. You need to remove 4 electrons. So 2, 3, 4. Then we'll have 1 unpaired electron and the C will be the right answer. I hope you understood this. Right? If you need to have 1 unpaired electron, then vanadium will have to be in the plus 4 oxidation number. Correct? And wherever it's in the plus 4 oxidation number, that is going to be our correct answer. I hope you understood this. Very simple. Moving on to question number 18 now. Back bonding in the BF3 does not affect. You understand the back bonding. BF3, same thing once again, just like we saw in the Cl2O. Boron has a vacant p orbital. And each fluorine here got the lone pairs. Each fluorine here. Correct? Each fluorine has a lone pair. You see the conditions. They are meeting the conditions. Lone pair, vacant orbital. Back bonding will be here. Here also back bonding will be here. Here also back bonding will be there. Because of the back bonding, electron density increases between the atoms and partial double bond character develops. Meaning, there will be more electrons than the single bonds. Meaning, bond order is increasing. Bond is not exactly single, it's little stronger than single. So it is impacting the bond strength, bond length. So let us see where we have bond length is being impacted. It says that does not impact. So this is impacted. So let's eliminate this option. Bond angle will come to that. Bond length is impacted, so eliminated. Bond order is of course eliminated, is affected. You saw that. Question is that, is the hybridization affected? No, hybridization is not affected in this. Steric number still remains the same. Hybridization still remains sp2. So hybridization is not impacted. What else? Lewis, if hybridization is not impacted, the geometry is not impacted. Geometry still remains planar. So planarity is also not impacted. You understand that? But bond strength, bond order, bond length, these are being impacted. One option says about the Lewis acidic strength as well. Is it impacted? Yes, it is impacted. Boron is electron deficient. Correct? Got just 6 valence electrons. These fluorines are decreasing the deficiency of electron by due to the back bonding. It is supporting by some electrons here. Correct? So deficiency of electron on the boron, that deficiency decreases, that goes down because of the back support in the back bonding. So Lewis acidic strength is not as much as you would expect. Correct? You are expecting that this has only 6 electrons. This is electron deficient. So according to that, you'll be expecting some Lewis acidity of this. But fluorine is supporting, the 3 fluorines are supporting it with the back bondings. So Lewis acidic strength of boron drops than expected. Correct? It is not as deficient as it seems to be without back bonding. Correct? So it says does not affect. Now let's check. It doesn't affect planarity. That's correct. Lewis acidic strength. No, that's where we'll eliminate this. Lewis acidic strength is impacted. Is the geometry impacted? No. So bond angle is not impacted. But just because of this, we'll eliminate this option. Bond length, is that impacted? Yes, that is impacted. Hybridization, is that impacted? Hybridization remains the same. And the bond length, bond strength is impacted. Bond angle remains the same. Planarity, no effect. Geometry, so this is our answer, option C. Option D, once again we can see Lewis acidic strength, that decreases, you understand. Bond length is shorter than expected, shorter than the single bond. Bond order, of course, PDCH, partial double bond character, will be there. So I hope you understood this. A very good question. Moving on to question number 19 now. Resistance of 0.1 molar. Okay, concentration is given to us, 0.1 molar of KCl solution in a conductance cell is 300 ohms. So resistance is given to us as 300 ohm, and conductivity, which is K, is given to us as 0.013. The value of cell constant, you know the relation between K and R. K equals to 1 by R into L by A. Do you know that this is what you call the cell constant? So basically they are asking you the value of L by A. Do you know the value of K? Yes, you know. Do you know the value of R? Yes, you know. Just put it in this. There is no problem of units. They are all in the this is in ohm, this is 7%. There is no problem of units at all. You understood this. Just put it over here and get the value of L by A. So L by A is going to be what? R into K. Let's put the values 300 multiplied by 0.013. Do the multiplication. Let's do some smart calculation. There directly 13 into 3, 39. And then 2 zeros. And decimal up to 3, so 3.9. That should be our answer. And 3.9. Okay, there are two options with the 3.9, you see. Which one are you going to pick? Right? Take care of the units. That is given in the 7 per centimeters. That's why you are going to pick option A. I hope you understood this. Moving on to next question. Question number 20. Consider the following structure. Okay. Let's consider this, and this. Okay. Which of the following pairs represent D and L fructose respectively? Let's check. D and L. So D will be where, first of all, fructose means it should be ketose, correct? And second, then on the last chiral carbon, you should have the OH group on the right hand side. So this, fine, that will be D. So this is eliminated, of course. That's not D. Okay. But in this, okay, in the D glucose, the OH on this position should also be on the right hand side. It's given on the left hand side, so that is eliminated for the D glucose. This L, D, yes, this is the correct answer directly from the structure. This is your D fructose. L will be when you have the OH group on the left hand side. So OH you have here on the left hand side, and here you have on the left hand side. But once again, this OH, you see, once again, directly from the structure. This is the L fructose. Directly from the structure, correct? I hope you understood this. Moving on to the next question. This will be 3 and 4. Okay. When the following skeleton equation is balanced with the smallest whole number, all right, stoichiometric coefficient of the species involved, what is the sum of a stoichiometric coefficient of hydroxide ion and the iodide ion? Okay, let's balance this. Basically, they are asking you to balance the equation. If you balance it, then only you will be able to get the answer. I minus plus MnO4 minus. Mark this, basic medium. So medium of the problem is basic. This gives us IO minus plus MnO2. You can balance it using any method. I will be balancing here by the oxidation number method. Okay. Assign the oxidation number. So this is minus 1 here. This manganese, calculate, plus 7. Oxygen minus 2. Iodine over here, minus plus 1. This manganese over here, plus 4. All right. Now, balance the atoms who are undergoing change. Iodine is undergoing change, already balanced. Manganese undergoing change, already balanced. Fine. Let us calculate the net change in oxidation number here. So, net change in oxidation number is going from minus 1 to plus 1. So, net change over here is 2 units. Correct? Minus 1 to plus 1 for the iodine, because that only is changing. Only iodine and manganese are changing. I hope you understand that. Correct? Manganese is going from plus 7 to plus 4. Only one atom participating, fine. So net change in the oxidation number will be 3. Now equate the change in the oxidation number. So how to equate this? This is 2, this is 3. So if you multiply this by 2 and this by 3, the change will become equal. Multiply to the corresponding couple also. This will be 3, this will be 3, 2 to this couple. Okay, balanced. Now you balance the charge. You have -3 here, -2 here, -5 this side, and this side -3. Basic medium problem, so you balance the charge using the OH minus. So you'll be needing 2OH minus on the right hand side. Charge is balanced. Now balance the oxygen. So you have 8 oxygen this side, 3 plus 4, 7, 7 plus 2, 9 oxygen, 8 already this side. So we will need 1 water molecule to balance the oxygen. And if you check, hydrogen automatically gets balanced. So this is our balanced equation. How will you check whether this is correct or not? So always check 2 things. Law of conservation of charge, whether you have the same charge on both sides or not. And then check law of conservation of mass, whether all the atoms are balanced both sides or not. Just check these 2 things. You'll get the idea whether your balanced equation is correct or not. Okay. These are already the smallest integer that we can have. Correct? While balancing. They are asking you hydroxide ion coefficient and iodide ion. So this is the iodide ion. The coefficient over here is 3 and the hydroxide ion coefficient is 2, and they are asking you the sum. So sum is going to be 5. So the answer should be 5. I hope you understood. Very simple question. To solve this question, basically you need to know how to balance the redox reaction in acidic, basic and neutral medium. Moving on to the next question. Question number 22. Compounds which can react with NaHCO3 to release CO2 gas. This is based on the simple concept that any acid plus base reaction produces another acid and base. The acid and base over here should be weaker than the acid and base over here. It always goes from stronger acid to weaker acid or stronger base to weaker base. I hope you know this principle. Based on that only you will be able to tell here, see, any acid you take, HX, I'm taking just any general acid. If you are treating it with the HCO3 minus, this is the basic part over here, correct? HCO3 minus. This will take the H plus from here, will become H2CO3, and then the other thing produced will be X minus. H2CO3 is nothing but CO2 in water. Correct? So basically, if they're asking you that who produces CO2, that means who produces H2CO3. Correct? Now see. This is acidic. Correct? Producing CO2 would mean H2CO3. Any acid on the right hand side, this acid, if that is stronger than H2CO3, then and only then that will be able to produce CO2, else not. I hope you understood. I will repeat it again. Any acid you take, any acid, if that is stronger than the acid on the right hand side, see, whatever acid and base you have on the right reactant side, they should be stronger than the acid and base produced on the product side. Correct? Then only the reactions are spontaneous and feasible. H2CO3 is an acid. You know that. This side also you'll have an acid. The acid on the reactant side, that should be stronger than H2CO3. Then and only then this reaction will happen, else not. So for that, you need to remember the acidic strength order. Among the few compounds that is given to us, sulfonic acid, they are very strong acids, then comes the picric acid, like that. Correct? So whoever are stronger acid than the H2CO3, they will be doing this. So first obvious option will be D, sulfonic acid. Phenols, no. Sulfonic acid, this will be the one. B will be the one. They are stronger acid than H2CO3. Now for this you will have to remember the order. HCl, any inorganic acid, is stronger than the H2CO3. Alkynes, no. Alcohols, no. Carboxylic acid, yes. Squaric acid, yes. So these will be B, C, D, G, and H. These will be your answers. How many we have? We have 1, 2, 3, 4, and 5. So you are going to have 5 compounds that will react with NHCO3 to produce a CO2 gas. I hope you understood the concept. You should, to deal with question like this, you should remember the acidic strength order. That only can help you over here. I hope you understood this. Okay, there was one more compound which I did not see. Which one I missed? Okay, 5 to answer I gave. Correct. Fine. Yes. Question number 23. 12.2 grams of benzoic acid. Okay. The mass of benzoic acid is given to you. What is benzoic acid? Benzoic acid is this. The mass of benzoic acid is given to you 12.2 gram. Fine. This is dissolved in 100 gram of water. Mass of water is given to us 100 grams. The freezing point of solution was found to be 0.93. Okay. So freezing point of water was found to be, okay. So they are telling you the final freezing point became minus 0.93. All right. So delta TF of water, should that be 0 minus 0.93? Basically, the delta TF is 0.93. Correct. The normal freezing point minus the freezing point that you expected. Just take the mod of that, 0.93. That is the change in the freezing point. Kf of water is mentioned to us. Kf of water is given to us as 1.86 Kelvin kg per mole. The number N of benzoic acid molecule associated, and you have to assume the 100% association will be what? Okay. To solve this question, there is a direct formula, you know that. If that formula doesn't come to your mind, in that case, how can we solve this? So we have the benzoic acid, fine. So let's take the benzoic acid. So benzoic acid formula, what is it? C6H5 and COOH. That is the benzoic acid. So C6H5COOH, let us say N number of this was required to give C6H5COOH. It says that they are associating, correct? N. And they are saying that there is a 100% association, right? There will be the 100% association, right? See, so for this, if you want to find the N for this, the number of benzoic acid molecules that associated, means they are asking you the value of N. Meaning in one molecule, how many benzoic acid associated? That's what they are asking you. To start with this, what you can do, you can say that T equals to 0, you have 1 mole of this. You didn't have any? Okay. When there is a time of reaction, there is a 100% dissociation, so no equilibrium over here. So when the reaction completes, just like alpha is the degree of dissociation, it tells you out of 1 how many mole will dissociate. Same way, the degree of association tells you from 1 mole how many mole will associate. All right. So from 1, it's you are getting 0. Okay. When you have 1 mole, from 1 mole there is a complete association. From 100% reacted. Just a minute. From 1, there will be 100%. The remaining will be 0. There is nothing remaining, correct? So there is a 100% association. 100% got reacted. How much of this will be formed? Okay. When N reacts, you get 1. When 1 reacts, you get 1 by N. So 1 by N will be remaining. 1 by N amount of C6H5COH whole N will be forming after the association. I is, the value of I is the actual number of moles that you get divided by the number of moles that you started with. So 1 by N. So 1 by N will be the, because beta is 1 over here. So 1 by N will be the value of I. Correct? Now, what else we have over here? Delta TF is given to us. Okay, so delta TF is mentioned to us. Can I write it as I into KF into molality? Delta TF mentioned, KF given to us. Molality we can find because we know the moles of the solute and we know the mass of the solvent. If we have these things known, we will be able to find I, and once we find I, we will be able to get the value of N. So let's put the values and get the answer. So delta TF is given to us as 0.93. So we'll be solving it on the next slide. So delta TF value is given to us as 0.93. What else is given to us? Mass of benzoic acid 12.2 grams and mass of water 100. Mass of benzoic acid is 12.2 grams, meaning moles of C6H5COOH will be 12.5 by 12.2 by 122, meaning 1 by 10 moles. All right. And mass of water is given to us, that is 100 gram, meaning 100, you need the mass of water in kilograms. So 100 into 10 raised to power minus 3, meaning 10 raised to power minus 1 kilogram of water we have. So we know the moles of benzoic acid, we know the mass of water. The molality of the solution will be 1 by 10 divided by 1 by 10. This is 10 raised to power minus 1. So basically molality is 1. Okay. So molality is 1. It's a 1 molar solution. What else? We have any other information? Yes, we have the KF of the water also given. So KF of the water is given to us as 1.86. Let's put it in the formula. Delta TF equals to I into KF into molality, which is 1. Let's put the values. Delta TF 0.93 equals to I into KF 1.86 into 1. What is the value of I that we are seeing over here? The value of I will be 0.93 divided by 1.86. Solve this. What do we see? We see it 1 by 2. But on the last slide, we got I equals to 1 by N. So 1 by N will be equal to 1 by 2, or we can say N will be equal to 2, and that will be our answer. So here we had one option. See, in this question, you will have to find the value of I. Once you find the I, then only you can find the value of N. Now, the relation between I and N, there is a direct formula in terms of the beta. You would have, in that formula, you would have taken the value of beta as 1. So based on the formula, so you can solve any day. This is just a case when you forget the formula. You should know the concept. It's always the total moles after association or dissociation divided by the number of moles before association or dissociation. So I hope you understood this. The correct answer for this will be 2. Moving on to next question. Question number 23. So we have done 24. Ag plus ion concentration in the saturated solution of Ag3PO4. Okay. If the answer is X into this, find the value of K. Okay. Ag3PO4. A salt. This undergoes dissociation. Just dissociate it. If it dissociate, this will dissociate as 3Ag plus PO4 minus 3. And for this, solubility product is given to us, which is 2.7 into 10 raised to the power minus 19. Okay. For this, can we also write it as KSP equals to, remember, x raised to the power x plus y raised to the power y into s raised to the power x plus y. Correct. So same way, KSP can be written as 3 raised to the power 3. Okay. Let us say solubility is S over here. So the concentration of this will be 3S and this will be S. We know that, right? So KSP expression can be written as x raised to the power x. So x raised to the power x, then stoichiometric coefficient here 1 raised to the power 1, and then s raised to the power x plus y. So 3 plus 1, 4. This is given to us as 2.7 into 10 raised to the power minus 19 here. Let us solve this. What do we get? 27. So 27 let's solve this. S raised to power 4 equals 2.7 into 10 raised to power minus 19. This 10, 27, 27 cancels out. S raised to power 4 will be, this goes up, 10 raised to power minus 20. So the value of S will be, the value of S is going to be 10 raised to power minus 5. How do you solve this? You understood this. Okay. The value of S is going to be 10 raised to the power minus 5. All right. But this is not what they are asking. They are asking you that you have to calculate the Ag plus concentration. Concentration of Ag plus. Concentration of Ag plus is 3S. That's not S. So meaning you have to find 3S. Let's put the value of S. Should it be 3 into S, which is 10 raised to power minus 5. And this is the concentration of Ag plus that we are getting. If the answer is X into 10 raised to power minus 5, then you need to find the value of X. You see, X into 10 raised to power minus 5. So the value of X is going to be 3 only. So that is going to be our answer. I hope you understood this. Last question, question number 25. The number of diastereomers excluding the enantiomers for the 1 bromo, 2 chloro, and 3 iodo cyclopropane. Okay, so first of all, cyclopropane, let's draw this. And then 1 bromo, so 1 bromo. On second, chloro, and on third, you have to do iodo. Okay. So you have to draw the different stereoisomers for this, which are not mirror images of each other, of course. Right? So let's start it. One possibility is that we keep all the 3 atoms on the solid wedge. Right? So this is bromine. We keep this also on the solid wedge. Iodine, and we keep this also on the solid wedge. Chlorine. See, this structure and all of going on the dash, bromine, chlorine, and iodine. Both of these structures are same. These two will not be considered different. Understand that, correct? This is just your different angle of view, correct? So if you view the same compound from behind, then this will look like this only, correct? So this is not a different compound, correct? These are not diastereomers. So one will be this. Now just do the different arrangements in this itself. You will get all the possible answers. Here, let's keep any two in one plane and take the third one in the different plane. So we are keeping bromine and chlorine in the solid. So bromine and chlorine in the solid, okay? So bromine and chlorine in the solid, and then take the iodine outside the plane, okay? Or bromine and chlorine on the dash and iodine on the solid. You understand it's the same thing, right? Then let's keep iodine and chlorine in the same plane and push the bromine in the opposite plane. So bromine goes on the dash, and then the chlorine and bromine, not bromine, iodine goes out of the plane. Now, once again, if you are thinking about this, that how about to take chlorine and iodine on the dash and bromine on the front? That will be the same structure, you understand, just the different angle of view. So we did this, we kept all the 3 in one plane, we kept these 2 in one plane, this out of the plane, we kept these 2 in one plane, this out of the plane. Now take these 2 in one plane and take this out of the plane. So this is going to be bromine over here, iodine in the same plane, and then chlorine goes out of the plane. Now there won't be any third possibility. You understand that? You had only 2 possibilities, either 3 in one plane or any 2 in one plane and 1 out of the plane. So you got only these possibilities, 1, 2, 3, and 4. There will be only 4 diastereomers for 1 bromo, 2 chloro, 3 iodo cyclopropane. I hope you understood this. So that's all. These are the questions that we had. We have discussed all the questions here. I hope you have understood everything. Just a minute. I guess I have not discussed one question. We'll just confirm that. Oh no, we have discussed all the questions. So that's all. That's the paper that we already have discussed. Hope to see you in the next session. So thank you for watching the session. That's all for the day, and all the best for your JEE exams. Thank you. Bye bye.
Mishra, your maths master teacher. Now today we will discuss RT-05 test paper discussion. Now let's start. Here, question number one. Wait. Here. In question number one, given that x1, y1, z1 and x2, y2, z2, x3, y3, z3 be three-digit even numbers, and this determinant evaluate. Now, how to solve this type of problem? Here, x1, y1, z1, x2, y2, z2, x3, y3, z3 be three-digit even number means x1, y1, z1, x2, y2, z2, x3, y3, z3 be three-digit even number means any even number unit digit divisible by 2. Now we check 24 is an even number, unit digit divisible by 2, 1, 2, 5, 6, 7, 8, 6 divisible by, unit digit is divisible by 2. This means this is a unit number. This implies that Z1, Z2, Z3 are even number. It's okay. Now evaluate this determinant expansion of expand along R1 del equal to x1 eliminate corresponding row corresponding column is y2 minus y3 y y2 minus y3 no sorry y2 into y3 here y2 into y3 minus of y3 into z2 it's okay y1 into z3 here y2 into z3 minus y3 into z2 again minus y1 corresponding row corresponding column eliminate x2 into z3 minus of x3 into z2 it's okay now z1 corresponding column corresponding row eliminate this means x2 yes z1 z3 x2 y3 minus x1 y2 x2 y3 minus x2 y3 minus x3 y2 it's okay now here z3 is an even number z2 is an even number this means difference of even number is also an even number z3 even number z2 is even number this means difference of even number is also even number here z1 is even number multiplied by any even or odd number is also is an even number this means this is an even number sum or difference of even number is an even number and as we know even number is divisible by 2. This means divisible by 4 but not necessarily divisible by 4. Okay. Now, next question, question number 2. If the sum of first n term of the series here root 3 and root 75 is written as root of 25 into 3 and root of 243 is written as 9 wait. It's 49. Wait, 49 into 3. Yes, 49 into 3, and next again. Here root 3, and this is written as 1 root 3, and this is written as 5 root 3 plus this 243 is written as 81 root 3. It's okay. 81 3 1 3 3 8 and this is a 9 root 3 similarly again 11 root 3 now if root 3 taken as a common means 1 plus 5 plus 9 plus and so on plus n term and sum of its digit given by 4 3 5 root 3 now root 3 cancel out. Sum of n even number means n by 2 to a plus n minus 1 into d. Here d is 9 minus 5 is 4 equal to 435 means yeah, n by 2 here 2 plus 4 and minus 4 equal to 435 and n by 2 this is 4n minus 2 divide 4n minus 2 equal to 435. Then here 2 taken as a common means n into n minus 1, 2 taken as a common multiplied by 2 into this equal to 435. Okay. Now wait. Here 2 taken as a common, this is a 2n minus 1 and if multiplied it by n, this means 2n square minus n equal to 435. Now, this is a quadratic equation 2n square minus of n minus of 435 equal to 0. Now, by using quadratic formula, this means quadratic formula is minus b plus minus root of b square minus of 4ac upon 2a. Here b is minus of minus 1 means plus 1 plus minus root of b square means 1 square 1 minus of 4ac means minus minus plus 4 into 2 into 4 3 5 divided by 2 into 1. It's okay. Now 1 plus minus simplify this 1 plus 4 to the 8 8 5 is 40 8 is 24 24 4 28 and 8 4s are 32 32 and 2 34 and here upon 2 into here a is 2. It's okay, means upon 2 into 2 4 means 1 plus minus this is an square root of 59 means this is an 59 divided by 2 into 2 4. If we taken plus sign means 1 plus 59 by 4, this is an 60 by 4 15 and again taken minus sign means 1 minus 58 by 4, this is an minus of 57 by 4. Number of term in negative number is not possible. Question number 3. Here, if A equal to given determine A equal to this matrix and determinant of adjoint of A equal to this. As we know, a property of adjoint of determinant adjoint of A is equal to determinant of A raised to the power of n minus 2 into A. Here we see order of this matrix is 3 means order of determinant is also 3 and here determinant of A 3 minus 2 is A means here we can see adjoint of A equal to this means determinant of A into A. Now determinant means determinant of adjoint of A. Okay, means this can be written as determinant of A into A. As we know, properties of determinant K A we here K is an any scalar and here also determinant of A is any scalar. And if K outside, if we take K outside, K raised to the power n into determinant of A Then we here we concluded the result. The determinant of A and order of determinant is 3 and this is an scalar and determinant of A. And here given that this value is equal to 14 raised to the power of 4 means determinant of A raised to the power 4 equal to 14 raised to the power of 4. It's okay. Here determinant of A equal to 14 to the power of 4. This means determinant of A equal to 14 or minus 14. Now, expansion of this determinant. If we take x1, eliminate corresponding row and corresponding column, this means this column and this row. 1 into 1, 1 minus of minus 2, this means plus 2. When if we take minus 2, this is corresponding cos C2 and R1 is eliminate. This means minus 1 into minus 1 minus 1 and 2 into 2 4 minus 4. If we take minus 1 corresponding column corresponding rows, minus 1 into minus 1 1 and 1 minus 2. Here we can see this expression 2 plus 1 3x minus 1 minus 4 minus 5 into minus 2 plus 10 and 1 minus 2 minus 1 and this is plus 1. It's okay. And this is written 3x plus 11. Now here we will get a result 3x plus 11 equal to 14 means 3x equal to 14 minus 11 3 14 minus 11 3. This means x equal to 1. But here not given x equal to 1 in the option. Now 3x plus 11 equal to minus 14 means 3x equal to minus 14 and minus 11 minus 25. One minute. Minus 25 by 3. Here a silly mistake in this option minus 25 by 3 is the correct answer. D part is the correct answer. It's okay. Now, in this question given that this question taken from the chapter trigonometry and basic trigonometry. Now here we see sine 1, sine 2, sine 3, sine 89. Now 2 times of, we listen carefully, sine 1 plus sine 89. Sine 1 and sine 89 को टुगेदर लिखने पे यहाँ पे बना हमारे पास साइन 2 प्लस साइन 88 एंड हियर साइन 3 प्लस साइन 87 एंड सो ऑन. नाउ नेक्स्ट, denominator will be not changed means cos 1 plus cos 2 plus cos 44 plus 1. It's okay. Here sine 1 plus sine 89 means sine C plus sine D. If we apply, 1 minute, it's okay. As we know, a trigonometry formula sine C plus sine D equal to 2 sine C plus D by 2 into cos of C minus D by 2. Let's say sine 2 sine C plus D by 2 means 1 plus 89. 1 plus 89 is 90 by 2 45, and sin C minus D by 2. C minus D by 2 means 89 minus 1, 88, 88 by 2, 88 by 2 is written 2 sin C plus D by 2 cos. Cos minus theta is also cos minus theta equal to cos theta, and here cos of 88 by 2 44, and here also 88 plus 2 90, 90 by 2, this means 2 sine C plus D by 2 means 45 into cos of 88 minus 2, 86, 86 by 2, here we say 86 by 2, 2 for the 2 theta, means cos of 43, and next again same expression is continue, 2 times of cos 1 plus cos 2, and next cos of 45 and plus 1. It's okay. Now in a numerator 2 sine 45, 2 sine 5, if we take a common 2 sine of 45, it's okay. If we take common 2 sine of 45, we will get the result cos of 44 plus cos of 43 plus and so on cos of 1 divided by 2 times of this expression is also written as is here cos 44 plus cos of 43 plus cos of 1 and plus 1. It's okay. Now 2 sine 45, sine 45 is what? Sine 45 is 1 by root 2, means this 2 is 2 cancel out, sine 45 is 1 by root 2. It's okay. And root 2 is 1 2 by root 2 is also written as root 2, and this expression, yes, here we mistake this question, 1 is not taken here, means 1 is here, cancel out, root 2 is our correct answer, means A part is the correct answer. Now first natural number, as we know the formula of mean of first natural number, sum of first and natural number this divided by n, this means n plus 1 by 2. It's okay. Where if we put n equal to 2k plus 1, if we put n equal to 2k plus 1 here, this means 2k plus 1 divided by 2, this means 2k plus 2 divided by 2 means k plus 1. Now mean here x bar is equal to k plus 1. And sum of first natural number 1, 2 through 5 and n, here mean is k plus 1, it's okay, k plus 1, k plus 1, k plus 1, and absolute value of this difference means 1 minus of k plus 1 a, 1, once again 1 minus of k plus 1 is minus of k, but absolute value is k. 2 minus of k plus 1 is minus 1 plus k, it's also absolute value is also written as k minus 1, k minus 2. Again last result is n minus of k plus 1, n equal to n put 2k plus 1, this is n minus k minus 1 minus 1 plus 1, and 2k minus 1 is k. K 2 times. Here just before first term k minus 1, k minus 1 2 times. It's okay. This means summation of xi minus x bar is 2 times of k plus k minus 1 plus k minus 2 plus and so on 1. means first of n natural number divided by n. Now apply the formula of first n natural number k plus 1 divided by 2. Here n is k n plus 1 divided by 2. It's okay. N plus 1 divided by 2, and 2n is also written as this. It's okay. Now n plus 1 divided by 2, n is also okay. Here 2 into 2 4, and this is written as k. Here k, to find k, 2k equal to n minus 1 by 2. This means k equal to n minus 1 by 2. When we replace n k equal to n minus 1 by 2, it's okay. N minus 1 by 2, here n minus 1 by 2, great. Yes, k n equal to k, this means n plus 1 divided by 2. It's okay. And replace n minus k equal to n minus 1 by 2 into n minus 1 by 2 plus 1 divided by 2 into 2. This is n 4 1. It's okay. Here our final answer is now here n minus 1 by 2 into n plus 1 by 2. This is simplified divided by 2 into 2, 2 and 2. Yes. Here minus 1 by 2, 2 times of this, and plus 1 by 2. Here 2 is to cancel out, k plus 1. It's okay. Means k into k plus 1 is, and then plus 1 by 2. It's okay. 2 times of here k plus 1 by 2. Here final answer is k plus 1. When put k equal to n minus 1 by 2, here n minus 1 by 2. This means this simplified that n minus 1 by 2 and n plus 1 by 2, and a plus b, a minus b, a square minus b 1 divided. Here n is remaining, k minus 1 divided by n. This n is also present here. This is divided by 4n, means n square minus 1 divided by 4n. Here B option is our correct answer. It's okay. Now next question. The area of sorted region bounded by this sorted region. This is to draw the graph y equal to 4 minus x square. This is an 4 minus x square. Again mod image of this with respect to x. And y equal to 3x. This is y equal to 3x, but mod of y equal to 3x. This region is our sorted region. It's okay. Now to find intersection point of this, means put y equal to 3x, mod of y equal to 3x in this equation. This means 3x equal to 4 minus of x square. It's okay. 3x equal to 4 minus x square. This means x square plus 3x minus 4 equal to 0. Now factorize x minus 1. This our factor is plus 4 and minus 1. X plus 4 and x minus 1 equal to 0. This means x equal to 1 and x equal to minus 4. Here this point is x equal to 1. When put x equal to 1 here, y equal to 3. Now here we integrate 1 2 3. If we integrate 1 2 3, this means 1 2 3, this curve mod of y equal to 3x plus, and 1 2 sorry 0 to 1. This is our, this point is 0, 0 to 1 3x, and 1 2 3, this point is 1, and 1 to 3 means this circle is radius is 2. Here 2 comma 0 and 1 to 2 this circle means y equal to 4 minus x square. This means this. Now integrate. 3 times of integration of x is x square by 2 lower limit upper limit plus here 4x minus integration of x square is x cube by 3 lower limit and upper limit. If now substitute lower limit and upper limit, here we get uh, 3 3 3 with the 2 3 by 2 if we put upper limit. And now to solve, this is a 19 by 3 to check calculation itself. Now this is 19 by 3 means 3k plus k by 3 equal to 19 by 3. 3k plus 1 by 3 equal to 19 by 3. This means 3k equal to 19 by 3 minus 1 by 3. This means 3k equal to here 18 by 3 means 3 6 18. This means 3k equal to 6 here k equal to 2. Means our option is B option is our correct answer. Now next question, the coefficient of x to the power of 3001 in this expression. Here we can see this series in GP means GP and common ratio is this divided by this means x upon 1 plus x. Okay. If we take common 1 plus x raised to the power of 500, here 1 plus, okay, uh, x upon 1 plus x square upon 1 plus x square and so on. Now let's see here start 0 and last 5 terms. It's okay. Now here taken x to the power 1, here x to the power 0 and here x to the power 500 means number of term what? 501. It's okay. Now as we know, sum of n term of GP is a1 minus r to the power n upon 1 minus r means 1 plus x to the power 51 minus r is x by 1 plus x to the power of 501 divided by 1 minus r means 1 by 1 plus x. Okay. Now let's see calculation. 1 plus x raised to the power 500. Here 1 plus x to the power 500. Sorry, 1 plus x to the power of 501 and here 1 plus x to the power of 501 minus of uh, x to the power of 501. It's okay. Here this is a numerator. If we solve denominator, uh, 1 plus x minus 1 divided by 1 plus x. It's okay. Now if we shift here, this means 1 plus x to the power 500, 1 plus x to the power 500 cancel out. This means this is our final expression is 1 plus x to the power 500 minus of x to the power 501. Now here our question is coefficient of x to the power of 301. This means as we know concept of the coefficient of x to the power r in 1 plus x to the power n is what? NCR. This means 500 C 301. Now here no term exists coefficient of 301. Now but our answer is 500 C. Wait. Here 501. It's okay. Means 501 3C01, but here not given in any option 501 3C1. This means we can again apply the property of NCR equal to NCN minus R. This means 501C, the 501 minus 301. This means 501C 200. It's okay. 501C 200. Here D option is our correct answer. Now Next question. If vector A, vector B, vector C be three vector, R is such that this expression can be written. If we simplify this means R cross B minus of C cross B equal to 0. This means R minus C, if we take in cross vector B equal to 0. As we know, if any vector A cross B equal to 0, this means both vectors are parallel and parallel vector written as A equal to lambda times of vector B. This means vector R minus vector C equal to lambda times of vector B, that equal to vector R equal to vector C plus lambda times of vector B. This implies that vector R equal to here vector C is given what, 5i minus 3j plus 3k plus lambda times of vector B be what, I minus j plus 2k. It's okay. Vector R equal to here 5i plus lambda I. It's okay. Minus of 3j minus of lambda j, and next 3k plus 2 lambda k. Now, if I taken as in common, I lambda plus 5 here minus j means lambda plus 3, and here k means 3, if taken 3 as a common, 3 plus 2 lambda. Now here given that vector r dot a equal to 0, this means r dot a equal to 0, taking dot product of this and this vector, I dot I means lambda plus 5, and j dot j means minus of here 2, means minus of 2 times of lambda plus 3, and k dot k means 3 plus 3 into 3 plus 2 lambda equal to 0, means 5 lambda minus 2 lambda minus 6 plus 3 3 is 9 plus 3 2 is 6 lambda equal to 0. It's okay. Now here 5 lambda minus 2 lambda, sorry, here 5 plus lambda, this means 6 plus 1 7, 7 minus 2 5 lambda, and here uh, 9 minus 6 3, it's okay, and any constant term remaining, yes, 5. 9 minus 6 3, 5 plus 3 8, means 5 lambda plus 8 equal to 0. This means lambda equal to minus of 8 by 5. Now substitute lambda equal to minus 8 by 5 here. We will get vector lambda equal to minus 8 by 5 put here, and vector r dot a, yes, we will get vector r. If we put lambda equal to minus 8 by 5 is here, we get lambda vector r. Now here we check the calculation itself. Lambda vector r equal to 79 minus 7j plus k. It's okay. And divided by 5. Now evaluate itself. 25 times magnitude of vector r square means to find magnitude of vector r. Now here we check the calculation also. Vector r equal to here this means magnitude of vector r means coefficient of I square, root of coefficient of I square plus j square plus k square, and here 339. This means our correct answer is square root of 339. Now next question, question number 9. If the equation of parabola whose vertex is 5, 4 and directrix is this means this is an parabola and this point is vertex. Vertex is what? 5, 4. And here fixed line is called an directrix. This means 3x plus y minus 29 equal to 0. This is an our directrix. And again given a plus b plus, the equation vertex, yes. Now find equation of parabola in this format and comparing this equation to find a, b, c, and d plus and k. Substitute the value to find a plus b plus c plus d plus k. Now, equation of to find equation of parabola, first we find fixed point is called focus, and another point, general point p, ps equal to pm, where eccentricity of parabola is ps equal to epm, and eccentricity of parabola is ps equal to pm. Here, our target is to find s. It's okay. And as we know that vertex is the midpoint of this foot of perpendicular and foot of directrix and this focus. Now, first our target to find this is an foot of perpendicular to this point. It's okay. Now, as we know, the formula of foot of perpendicular x minus x1 upon a, y minus y1 upon b equal to minus 2 times of ax1 plus by1 plus c upon a square plus b square. Now substitute x1 y1 here, x1 y1, this means x minus 5 and a here, a is here 3, y minus 4 upon 1 equal to minus 2 times of a x1 means 3 into 5 plus 1 into 4 minus 29 upon a square plus b square. What is b? B is n 1. Now solve this expression, we will get n 1. To check itself, x minus 5 by 3 and y minus 4 by 1. When x minus 5 by equal to 3, this means x minus 5 equal to 3. Here we will get x equal to 5 and y equal to 4. Means our this point is foot of dielectrics means 5 comma 4. Let us assume this point is h comma 4 means vertex is the midpoint of both the point. This means midpoint. It's okay. H comma k. Now h plus 5 by 2 equal to 5. Wait. Here x coordinate is 8. 5 plus 3 here x coordinate is 8. It's okay. X coordinate is 8 means 8 plus 5. H plus 8 divided by 2 equal to this means h equal to 2, and similarly k plus 4 by and k equal to y coordinate is 4, it's okay, and here k plus wait sorry, here given y minus 4 equal to 1, this means y equal to 5. Here y is equal to 5. It's okay. Y equal to 5 means k equal to k plus 5 by 2 equal to this means k equal to 8 minus 5 3. Now this point is 2 comma 3. Now applying the condition of is okay. Now apply the condition of parabola. Here P point is an our general point x comma y. Here focus is it's okay. And here find focus is 2 comma 3, and here directrix equation is what is dielectric equation means 3x minus y 3x plus y minus 29 equal to 0. Now applying the formula of ps equal to epm, eccentricity is 1. Ps means square root of x minus 2 square plus y minus 3 square equal to e is and 1 perpendicular. Now to find perpendicular distance means 3 into 2 plus 3 minus 29 divided by root of 3 chi square 9 plus 1 square 1. Now squaring on both sides, we will get answer is this type. Squaring on both sides to check, here we check the calculation. Here we will check calculation and compare this equation to find A, B, C, D plus K and solve. This is our final answer, means 576 is our final answer. Next question. Integration of fx equal to this type of problem. How to integrate inverse trigonometric function? By using integration by part, but here given that integration of fx equal to gx means integration to this type of to integrate and convert it in the form of gx. If we differentiate both sides, means fx equal to g dash x and f dash x equal to g double dash x. Now let us assume f inverse x equal to t. Okay, this means x equal to ft when differentiating on both sides, mean dx equal to what? Ft dt. This means integration of f inverse x, f inverse x t, and x is what? F of t dt. It's okay. Now by using integration by part, okay, now using integration by part, t as a first function, ft as a second function. One here our option is g dash x. This means ft is also written as g dash x. This means t into g dash of wait. Now first we integrate then put. It's okay. First we integrate to this expression. By using integration by parts, first this is in our first function. Dx here, yes, okay. Dx equal to f dash t here, f dash t, and if we put f dash t equal to g double dash x, and this is t into g double dash x, but here integrate with respect to t. This means g double dash of t dt. Now let this is a first function and this is a second function. By using integration by part, what is an integration by part? First to into second function, first here is same integration of second dx and minus of differentiation of first into integration of second dx. Now integrate t into g double dash x, integration is g dash t minus differentiation of first is this, and g dash t is g dash of t. Here t times of gt, integration of this means gt. Now but our option is not in this format. Now substitute t equal to f inverse of x. It's okay. Now substitute t equal to f inverse of x, means g of f inverse of x minus g of f inverse of x. Now relate the option here. What option will be correct? Means x f inverse x minus g of, yes, B option is our correct answer. Now let's start next question. Mod of z minus 3 minus 2 iota equal to this, where z is a complex number, then the minimum value of this. Mod of z means circle with center 0. Okay, and minimum means to solve this equation and to find shortest distance, means minimum distance. It's okay. Let z equal to x plus iota y. It's okay. If we substitute z equal to x plus iota y minus 3 minus 2 iota, this means x minus 3, if we take common here, x minus 3, if we take common I, this means y minus 2. It's okay. And here magnitude of this, and again put z equal to x plus iota y, here plus 2 iota. This means this is also written as x plus iota times of y plus 2. Now to find magnitude of complex number, this means square root of real part of square plus imaginary part of square. Here also square root of x square plus imaginary part of square means y plus 2 square. Again squaring on both sides and we will get the result 6x plus 8y equal to 9. It's okay. Now here apply a minus b square and mod of z will be, this means distance of a line from the point 0, 0, 6x plus 8y plus 9. Again substitute here is 6 into 0 plus 8 into 0. Uh, Here minus 9 because equal to 9. Minus 9 divided by root of a square means 36 plus 64. This here 0 means modulus of minus 9 by 10 means 9 by 10 is our correct answer, means option D is our correct answer. Now next question. How many 6-digit number are there in which no digit repeated? Even digit appear at even places. It's okay. Even digit. Now here 6-digit number 1, 2, 3, 4, 5. Now divisible by 4. Any number divisible by 4, this means last digit is divisible by 4. Places is here first, second, third, fourth, fifth, and sixth. It's okay. Now last digit is divisible by 4. What value? What can take last digit? 1, 2, 1, 6. Because starting with 1, this is an fifth place. Fifth place means fifth place is an odd number. The fifth place is start only odd number. 3, 2, 3, 6. Again 5, 2, 5, 6. Next 7, 2, 7, 6. And 9, 2, and 9, 6. Okay. Now count 2, 2, 2, 2, 2. Here 10 means last two digit can be filled in 10 bases. It's okay. Now 1 to 9, 0 to 10 means 4 digit even. Sorry. Here can be written 1, 2, 3, 4, 5, 6, 7, 8, 9. Here 0 is also. It's okay. This is an 10 digit, 5 digit even, and 5 digit 10 is an odd number. It's okay. In a 5 digit, here first place is an to take an odd number. Odd number what? 1, 3, 5, 7, 9. But here one odd number is also used, so remaining odd number is 4. It's okay. And third place is an odd number, remaining odd number is 3. Now same here is even number, what value? 2, 4, 6, 8 and 0. But here one even number is also used. This means this place can is full, and again same process this by using fundamental principle of counting 4 into 4 into 3 into 3 into 10 and multiply this, and we will get 1440 is our correct answer. Now next question, find the value of A has a local maxima. Local maxima, this means here this point is a local maxima. Means here neighborhood of 3 is f3 is greater than neighborhood of 3. It's okay. This means f of 3 is greater than f of 3 minus. It's okay. Equality of 3 is here. This means f of 3 means x minus 18 is greater than, now here f of 3 minus means 3 minus that function is given, means put x equal to 3, 3 put x equal to 3 here, put x equal to 3 means 4 3 is a 12 minus 3 3 is a 9 plus log of a square minus 3a plus 3. It's okay. Now 3 minus 18 is minus 15, and here 12 minus 9 3, wait 3, 4 3 is a 12 minus 3 cube here 27. It's okay. this is an our minus 15 plus log of a square minus 3a plus 3. It's okay. Minus 15 shift here means plus 15. This means 0 log of a square minus 3a plus 3 is less than 0. It's okay. And also log is defined. This means a square minus 3a plus 3 is greater than 0. This is always greater than 0 because here d is less than 0. D means d square minus 4ac means 3 3 is 9 minus 4ac means 12. This means, sorry, d less than 0. D less than 0, this means graph is upward or below. This means this value, this quadratic value is always greater than 0. Now solve here. If log BC to shift here, this means a square minus 3a plus 3 is less than a to the power 0 means a square minus 3a plus 3 less than a exponent of 0 is and 1. This means a square minus 3a when here shift 3 minus 1 is 2 is less than 0. Now factorize here a minus 2 a minus 1 is less than 0 here 1 and 2 plus minus plus this means our value is 1 to 2. It's okay. Here equality is also hold because here given. Okay, this means a less than equal to 0 means here 1 to 2 is our correct answer. It's okay. Now next question. This question seen that log of b base a means by using the property of log a base b is also written as what? Log a upon log b. It's okay. And if x tends to 0, 1 minus sin x is approach tends to x and log of 1 plus y if y tends to 0 is written as a y because log of graph x-axis y tends to 0 means approximate same value. It's okay. Means this expression is written as log first we use this property. This means log of 1 minus sin x divided by log of 1 plus sin x. Again here, next term is log of 1 minus sin square x upon log of 1 plus sin square x. Here same 1 minus x is written as minus x. Here is works. 1 this is minus x x. How many times? This is written 2014 times means minus 1 raised to the power 2014. This means our correct answer is 1. Okay. Now, next question. Find the value of this. Any expression this type now, then this is also written as 1 plus factor of 2 means if lambda is common, lambda plus 1 and difference create difference lambda plus 1 minus lambda. Now apply the formula tan inverse of a minus b. Okay, tan inverse a minus tan inverse b. This expression written as tan inverse a means lambda plus 1 minus of tan inverse of lambda. Here lambda, what value of lambda? Substitute lambda equal to 1. This means lambda equal to 1 means lambda inverse 2, lambda inverse 1 when we put this lambda inverse 2 and so on. Last is lambda inverse of 6 minus lambda inverse of 5. Here this expression is cancelled out and remaining expression is tan inverse of 6 minus of tan inverse of 1. By using the formula tan inverse A minus tan inverse B, this means tan inverse of 6 minus 1, 1 upon 1 plus 6 into 1. This means tan inverse of 5 by 7. But here outside is cot, this expression also written as cot inverse of 7 by 5. And here cot and multiplied by 5, it eliminate cot of cot inverse. This means 5 into 7 by 5. 7 is our correct answer. Now, next question. The triangle PQ are inscribed in this circle. In this circle here given that circle with center 0 and radius r, radius 5. By comparing this equation, x square plus y square equal to 25 means center is 0, 0 and r is 5. Okay. Q and R two coordinate. Here Q is an any point 3, 4 and R is any point minus 4, 3. It's okay. Now QPR. P is any point on this circle. Just okay. Yes, okay. P is any. Here center is 0, 0 means this circle is center 0, 0. Now to find slope of OQ. What is the slope of OQ? Means 4 by y2 minus y1 upon x2 minus x1. And slope of OR? y2 minus y1 upon x2 minus x1. It's okay. Now here see that slope of OQ into slope of OR is minus 1. When this result is minus 1, this means this angle is what? Wait, means both lines are perpendicular. This means is 90 degree. As we know the formula of class 10, if any arc subtend an angle center is double to the any point of the center. This means this angle is 45 means pi by 4. Here C option is our correct answer. Now next question. This is an event function. What will be this interval? It's okay. Event function, this means f of minus x equal to fx. It's okay. F of minus x means f of x here given x to the power 4 plus 1 divided by a into sin x plus cos x plus e to the power x plus e to the power minus x by 2 here. This is given fx. Now here written as f of minus x. This means x to the power 4 plus 1 divided by a into sine of minus x is minus of sine x. And no change here. Cos x plus e to the power x plus e to the power minus x by 2. This is now cancel out. When this is left hand side, this expression, this means 2 times of sine x and x to the power 4 plus 1 upon a, so okay, equal to 0. This means x to the power 4, wait, yes, x to the power 4 plus 1 upon a, determinant of a equal to 0. As we know, any greatest determinant as a greatest integer 0, this means x is greater than 0 and less than 1. This means x to the power 4 plus a upon a greater than or equal to 0 and less than 1. This means a is greater than x raised to the power of 4 plus 1. This means what will be the put minimum value of a? What? Minimum value of a is minus 4. It's okay. Minimum value of a is minus 4. This means if we put minimum value of x, this means 4 to the power 4, 256 plus 1 means c is greater than 257 to infinite. Here C option is our correct answer. Now, to find shortest distance between the line. As we know, the general format of shortest distance is x minus x1 by a1, y minus y1 by b1 and z minus z1 by c1. And another equation is x minus x2 by a2, y minus y2 by b2 and z minus z2 by c2. As we know, shortest distance between this line is formula x2 minus x1, y2 minus y1 and z2 minus z1. And here a1, b1, c1 and a2, b2, c2 upon square root of a1, b2 minus a2, b1 square. Next here B1 C2 minus of B2 C1 square, and here A1 C2 minus of A2 C1 square. Okay. And to find here x1 y1 z1, x1 is 3. Comparing this format expression, y1 equal to 8 and z1 equal to 3, and x2 equal to minus 3, y2 equal to minus 7, z2 equal to 6. Substitute these value and solve this expression. Here we will check the calculation, and I hope easily to solve this expression, and 3 root 30 is our final answer. Now, next question is here. Y equal to yx is a solution of this differential equation. This means here to see this equation is the format what? Dy by dx plus py equal to what? Q. Here p is equal to tan x, p is tan x, and q is what? X sec x. It's okay. Now, to find IF, IF means what? E to the raised to the power of p dx. This means E. What is p? P is our tan x into dx. What is the integration of tan x? Integration of tan x is log of sec x. This means IF e to the power log x equal to x, means IF is sec x. Now, solution of this differential equation, y into if equal to integration of q. Q is what? X sec square. Wait, x sec x into here sec x. Okay, means y into sec x equal to integration of x sec square x dx. It's okay. Now, solve this equation y into sec x integration by part by using Euler rule ILA. This means first function, this means second function. Integrate here. First function is same here. Integration of sec square is tan square x minus of differentiation of first is 1 and integration of again here tan x. Okay. This means y into sec x equal to x tan x and integration of tan x again here. What is integration of tan x? Means log of sec x plus c. Now to find c, here will be given the condition, put x equal to 0 and y equal to 1. Here put x equal to 0 and y equal to 1, 2 we will get c equal to 1. Try to find c equal to 1 itself. Now, what will be to find? Y pi by 6 means put x equal to 6 and c equal to 1 here. X equal to pi by 6 and c equal to here. This means y equal to pi by 12 plus root 3 by 2 ln root 3 by 2 plus root 3 by 2. You can also solve this equation. Here A option is our correct answer. Now, next question. All the spades are taken out from deck of 52 card. Total spade card is 13. It's okay. Now, from these cards are drawn one by one without replacement till ace of spades come fourth draw. Means spade not come in first drawn, spade not come in second drawn, spade not come in third drawn, and spade comes in fourth draw. It's okay. In 13, total out of 13 card, spade is not coming in first card. Means what? Spade is not coming. So means 12 by 13. When this spade is outside, this means 11 by 12, and this spade is outside means 10 by 11. When fourth card is spade means 1 by 10. Now by using total probability theorem, 10, 10, 12, 12, 11, 11 means 1 by 13 is our correct answer, means C part is our correct answer. Now, next question, the image point of A in y-axis. What? this is an x-axis, here this is an y-axis. Image point of A point is here 3, 4. Image point of A in the y-axis here point B. It's okay. Image point of A in the y-axis means this coordinate is -3, 4. B in the x-axis, image point of here this -3, -4, and this is an C is D coordinate is 3, -4. Now see what is this shape is formed. This shape is rectangle. It's okay. To what 4, 4, 3, 3. This means here total distance is 6, and here total distance is 8. Then area of quadrilateral means area of rectangle is 8 into 6 equal to 48. Okay. Now next question. Let f and g be two real value differentiable function and f dash x upon z dash x equal to this. And what multiplied this here we will get f square x into f dash x minus of g square x into g dash of x. It's okay. It's okay. Now here this expression, what will be the function differentiation of this? Means f cube x minus of g cube x. Now differentiate, here we will get 3 times of f square x minus into f dash x minus of 3 times of g square x into g dash of x. It's okay, equal to 0. This means f square of x into f dash x minus of g square of x into g dash x equal to 0. This means this is both are equal to 0. This means this is a constant function. This means here given that f10, g10 2 and f2 means if we put x equal to 10 in both sides means what value get wait. Here this means this is a constant function means x cube of 10 minus of g cube of 10 and again put x equal to 2 means f cube of 2 minus g cube of 2. Now substitute this value, f of 10 is 5, this means f of cube 10 is 125. It's okay, g of 10 is 2 means 2 cube is an 8, f cube of 2 this find out, and g cube of 2 is 1. 125 minus 8 means 117 plus 118 means f2 cube is 118. Now next question, if x less than 0 maximum, both draw the line and what will be the maxima graph, and this is a minima graph. It's okay. Now draw the graph here. Y equal to x plus 1 means x equal to 0, y equal to 1. This is an y equal to x plus 1 and this graph is y equal to x minus 1. And here given that for x less than 0, what is the maxima? X less than 0 maxima graph is here. It's okay. And now next graph we draw 1 plus x square. It's okay. 1 plus x square and 1 plus x. This graph is given 1 plus x and 1 plus x square graph is here. Now minima is here. This. Now n is the number of continuity. To draw the graph here, this no point here, no jump point to find, and number of continuity to, if we draw the graph, if no if there is no hold pen means when any graph is smooth without pen holding means this function is continuous, means number of continuous point is 0 and number of differentiable, here we will get one sharp corner, here we will get two sharp corners. Okay, means number of differentiable point is 2, this means I'm equal to 2, and addition of both 2 plus 0 equal to 2, means here 2 is our correct answer. It's okay. Now next question, this type of problem, it always we check in plus 1. It's okay. And here we check the calculation to find in and in plus 1. This means both are equal. It's okay. If both are equal, then we substitute n equal to 1 and evaluate this 1 to 9. It's okay. Now if we put n equal to 1, this means 0 to pi by 2 sine of 2 into 1 into x into cot x is also written as cos x upon sin x. Now by using the formula of sin 2x, this means 2 sin x into cos x and divided by sin x. This is and cancel out 2 times of 0 to pi by 2 of cos x. And here I1, I2 is also same. By using reduction formula or Wallis formula or cos square x is also written as 1 plus cos 2x by 2. Here 2 is also 2, 1. If even power, Wallis formula is pi by 2. This means our final answer is what? 2 is here, pi by 2. It's okay. What times? 9 by 2 times. So means 2 by pi into 9 times of pi by 2. This means this is and cancel out. 9 is our correct answer. Now here next question is root of this quadratic equation. It's okay. Now let z square equal to t. Okay. Z square equal to t. This means this is written as t cube plus t square equal to 2. Okay. If we shift here t cube plus t square minus 2 equal to 0. Here we can see t equal to 1 is a factor. It's okay. If t equal to 1 is a factor, this means this cubic polynomial is factorized and this expression is written as what? This expression is written as t minus 1. If we divide, it's okay. If we divide, we will get t square plus 2t plus 2 equal to 0. This means here this is a factor t equal to 1. By using quadratic formula, minus b plus minus root of b square means 4 minus 4 into a into c means 8 divided by 2 into 1. Minus 2 plus minus 4 minus 8 is minus 4 and 2 into 1 2 and minus 2 and this is also 2i divided by 2. This means minus 1 plus minus iota. This means other two root is minus 1 plus iota and minus by minus iota. Now substitute the value of here t, because z square equal to t. Here z square equal to t means z square equal to t means z square equal to 1. Again if we substitute z equal to minus 1 plus iota, here we easily say the calculation z square equal to 1, z square equal to this, z square equal to this. To find z to the power 4, it's okay, what I1 equal to 1 to 6. Z to the power 4 equal to 1, z to the power squaring on both sides here, z to the power 4 here easily we check the calculation and to find this z I to the power 4. This means 1, 2, 3, 4, 5, 6 means 2 times of z1, z2, z3. This means our correct answer is 5 to 10. It's okay. Thank you.